Okay, good morning to all the machas and machis out there. 1 second now, just connecting to the audio. Just let me know if I'm clearly visible and audible to you all. Where is the pen? Okay, 1 second. Let me just check. Are we live? Yes, we are live. And yes, hi, hello everyone, good morning. Okay, I am. Just give me a minute. Yes. Okay. So, how are you all? Good morning, everyone. Good morning. Hi, Nisha. Hi, good morning, Mohammed, Vidya. Yes, good morning, everyone. Yes, thank you for asking. Breakfast done. I think you're telling yours or something. Yes. Good morning. Yes, good morning. Why is your name unsuccessful followers? So am I clear? Just to ask you all, am I clearly audible to you all? Clearly visible, right? There is no issue with the audio. If I'm clearly audible and visible to you all, you give a thumbs up. Okay, good morning, it's me Zainab. Yes, good morning everyone. Yes, good morning Shri Raksha, Vimala. Okay, yes, I'm clearly audible. Yes, just give a thumbs up, then we're good to go. Okay, yes, thank you so much. Thank you everyone. So anyways, you all know what are we going to do today? We are going to do complete chemistry revision. Yes, we'll be solving 100 questions today. So are you ready? How's the Josh, guys? Had breakfast? Yes, thank you everyone. Yes, had breakfast? All ready? Yeah, all set to go? If we only study these questions, how many marks can we get, ma'am? So see, I can't tell you how much marks, but it's written here 45 plus pakka, right? So the concepts will be used, the concepts that we will use in these questions will be utilized in your exam. So yeah, in a way it will help you score 40 plus, 45 plus. Okay, I can't give you the exact question obviously, case I'm not the KCET paper setter. But whatever concept we'll be using today, that is from the most repeated PYQs, most repeated questions, okay? And yes, the same question, concept question you will see in your exam, okay? Okay, so let's start, shall we? Okay, how's the Josh? How's the Josh, guys? Okay. So, yes, let's start, shall we? Give me a thumbs up if you're ready to start, or we're just starting, huh? It's a long live. And one more thing, before we start the live, I'm just clarifying it. It's going to be a long live because we are solving 100 questions, right? So 100 questions take time. So don't come in between and ask me, ma'am, how long class, okay? We'll give you a break, don't worry. In between, I'll give you a break. But let's solve in a continuation, okay? Yes. Okay. So, wait, ma'am. Yes. Yes, you should. No go study, it will be kind of a revision for you, okay? It won't be like you are already scoring this much in mock test. That means it will be a good revision for you, okay? Yes. Okay, don't worry. Let's cook together. Yes. Okay. Okay, let's start with the first question. Okay, first question here. Tell me, which of these represents correct order of increasing bond order? So you calculate the number of electrons first, right? You calculate the number of electrons first. Okay. Now, here, how many electrons are there? All of same. Four atoms are there. These 4 elements are there. 4 atoms are there, which are all are same. Okay. So we'll just calculate. C2 2 negative. That means 12 minus means plus 2, 14 electrons, right? Helium 2 4 minus 1. That means 3 electron. O2 plus 16 minus 1. That is 15 electrons. And 16 minus means plus 1, which is 17 electrons. These are the number of electrons they have. Okay. as I told you, when we have 14 electrons, the bond order is 3. So that means for C2 2 negative, the bond order is 3. Now as we go down or up, either we increase the number of electrons or decrease the number of electrons. In both the cases, the bond order shall decrease by 0.5. So we are going from 14 to 15. So that means for O2 positive, the bond order shall be 2.5. For 17 electrons, O2 negative, the bond order will be how much? 16, 17, right? 2.2, and you will have 1.5. And for 3 electrons, for He2 positive, the bond order is around 0.5. So now you can arrange very easy, right? That means C2 2 negative will have the highest, yes, B, correct. C2 2 negative will have the highest bond order and He2 positive will have the lowest bond order. Correct answer is option B. Okay? Easy, very easy, yeah, right? Very easy start. Yeah. Next question. Pick up the incorrect statement. Read the question, you have to tell the incorrect statement. So dipole moment ammonia is due to orbital overlap and resultant dipole in the same direction. Okay, so orbital dipole and the resultant dipole in the same direction, that is correct, because in ammonia the dipole moment, we have a lone pair, right? There is a dipole moment of lone pair, this lone pair. Similarly, these 3 hydrogens are also there. These their dipole moment also align. Their dipole moment also align with that of the lone pair, with this orbital dipole. Okay, and the resultant dipole are all in the same direction. Yes. So which is the incorrect statement? No. Oh, Jaya, no. Listen. Incorrect statement we are looking for. We are looking for the incorrect statement. In BF3, bond dipoles are higher, but dipole moment is 0. Yes, in BF3 there is bond dipole, right? Because F is high electronegative between boron and fluorine, right? In BF3 bond, you have dipole moments, right? The dipole is facing in the direction of fluorine, right? But the overall dipole moment, the resultant dipole moment, net dipole moment is 0. But the dipole moment is 0. Why? Because the resultant dipole moment for these two is pointing in this direction. For this one is in exact opposite direction, and that cancels out. And that means we have 0 dipole moment. Okay. Dipole moment is a vector quantity. Obviously, dipole moment has a direction. Yes, D is the incorrect answer. Why? Because they do not have a dipole. Why? Because O2 and H2 are homoatomic, right? They have same atoms, and same atoms do not have electronegativity difference, thus no dipole moment. Yes, now everyone is answering correctly. That is D. Yes. Manoj, Asif, Sudhir. Yes, good. Ma'am, by following this properly, can I score 40 marks? Please reply, ma'am. Purnima, by following this, yes, you will be able to have the knowledge of the concept that are going to come in your exam. So obviously, in a way, it will help you score 40 marks. Okay, so it's like complete revision. All the questions are there from your PU1, PU2. Obviously, if you solve them seriously, if you understand the concept, like dipole moment concept we understood here, right? And if similar question comes in your exam, you will be able to answer it, bacha, right? So in a way, in that way it will help you. Okay, yes, please, first question. Okay, can you explain option B? I can explain option B. BF3 bond dipoles are higher, but dipole moment is 0. That means that in BF3 there is bond dipole. The bond dipole moment is there, right? That is there in BF bond, in this BF bond, and in this BF bond. All 3 BF bonds have a dipole moment, but the dipole moment is 0. So it should be written, but net dipole moment is 0. Yes, because the net dipole moment of BF3 is 0. That's what you mean. Okay, yes. Don't worry, Muskan, we all are here. Okay, we'll study together and you won't be any weak. Okay, it's vitamin E. It will help you with the deficiency. Okay, okay, done. Yes, next question. Ma'am, please, first question. What was there in first question? Bond order, right? Macha, you need to know that when we have 14 electrons, the bond order is 3. That's all. When you have 14 electrons, the bond order will be 3. And if you go above 14, 15, 16, 17 electrons, or if you go below 14, 13, 12, 11 electrons, the bond order shall decrease by 0.5. That concept we used here. And if you have any doubts, you can go check the chemical bonding lecture, the live I have took in the rank booster series. There I have explained it really well. Okay, but since we are solving 100 questions today, I can't repeat every question in such a distance, right? I have covered it like in a very explanatory, yeah, very good explanation is there, so you can watch it. Okay, if you have any doubt in that particular chapter, right? Because they are chapter wise questions. Here we have mix match. Okay, that's the trick. Yeah, that's the trick for your competitive exam. That's the trick, because you can't write that whole MOT and everything. Yes, next question. Vidya, I've already told you class duration will be long. Okay, so be ready. We have to solve 100 questions, so you can take an idea, have an idea how long this class is going to be. The pair of species that has the same bond order in the following. Same bond order means, in my mind it goes same number of electrons. If same number of electrons are there, the bond order shall be same, right? So look for the combination which has same number of electrons. Tell me the combination which have same number of electrons. So according to, yeah, which is it? Tell me, it's very easy. 14 electrons, 7 plus 8 minus 1, 14 electrons, right? Same number of electrons, same bond order. Same number of electrons equal to same bond order. Yes, A, yes. Okay. Done. Rest of these, let's check. They don't have the same number of electrons first of all, okay? And if they do not have the same number of electrons, the bond order shall not be same. Yeah, very easy question. Yes, I know. And all of you are answering correctly. Next question. In which of the following pair both the species have sp3 hybridization? Tell me which of the following have sp3 hybridization. How many number of electrons are there in O2 and N2? Can anyone tell me? I think O2 have 16, this have 14. Electrons are not same. How will be the bond order same, right? Anyways, okay. Which of the following pair have both have sp3 hybridization? sp3 hybridization. Okay. sp3 hybridization. Very easy. Tell me which of the following have sp3 hybridization? Yes. Correct answer is B. Why? Because H2O. In H2O. How do you calculate hybridization? You have two methods, but I'll tell you the one that I use. V plus M minus C plus A. So if you are calculating hybridization for any atom, half of number of valence electrons of that atom plus number of monovalent atoms minus the charge of cation plus the charge of anion. Okay, minus the charge of cation plus the charge of anion. Now see here, in case of NF3, N, we are calculating the hybridization for nitrogen, half of number of electrons of nitrogen, valence electrons of nitrogen are 5. How many monovalent atom? Monovalent means single valency atom. Fluorine, 3 fluorines are there, plus 3. So that is 4, right? 4 means the hybridization is sp3. Similarly for H2O, if I calculate for oxygen, half of, how many valence electrons are there in case of oxygen? 6. Plus, how many monovalent atoms are there? 2 hydrogens, 2. 6 plus 2 by 2, that is 4. Again sp3. Okay. Now, listen. BF3 have sp2 hybridization. BF3 have sp2 hybridization. So that means this is not the correct answer. SiF4 BeH2. BeH2 have sp hybridization. BeH2 have sp hybridization. Okay? Clear? Okay, yes. Make, ma'am, another way to calculate the hybridization. The another way to calculate the hybridization is you should have an idea about structure. For this, you need not to have an idea about the structure, but for that other process, you need to have an idea about the Lewis structure. If you know the Lewis structure, then in that case, your hybridization will be equal to number of sigma bonds plus number of lone pairs. Okay, number of sigma bonds plus number of lone pairs. For example, in case of BeH2, the structure is this, right? So number of sigma bonds is how many? 1, 2 sigma bonds. Okay, what are the number of lone pairs? 0. Steric number is 2, and steric number 2 means the hybridization is sp. Okay, that is the second method. Addy, yes, through steric number it is easy to calculate, but you should have an idea. Remember, okay, what I am telling you, listen carefully. You should have an idea about Lewis structure. And if this technique works for you, if you already know this better, if you know the Lewis structures and if you know this method better, then use that. Whatever suits for you. For me, this works. I use that. For you, if this works, use that. Obviously, it's about that exam, right? Okay. Yes. Okay, Amaya, what you did not understand in this one? Steric number is better than use that. I'm not fighting here about the methods and everything, okay? So don't waste your time or mine here. So we calculated the hybridization here. Which of the species have sp3 hybridization? This is the formula that we used. That is a formula to calculate steric number. Okay, steric number is half number of valence electrons plus the monovalent atoms minus the charge on cation plus the charge on anion. So we calculated for NF3, nitrogen have 5 valence electrons, 3 monovalent atoms, fluorine. There is no cation or anion charge. That means steric number is 4. Steric number 4 means 1s and 3p. 1s and 3p. Similarly for this one, half, again V plus M minus C plus A we did for H2O. Oxygen has 6 valence electrons plus 2 monovalent atoms are there which are hydrogen. Again same hybridization. 4 steric number is 4, hybridization will be sp3. So the correct answer is B. Next question. In which of the following ionization processes the bond energy increases and the magnetic behavior changes from paramagnetic to diamagnetic? One more thing, bond energy also increased. Bond energy also increased. Okay. Now check the bond order. If bond order increased, if the value of bond order increased, that means what happened? The bond energy also increased, right? Bond order means you should have an idea, you should have these concepts till now, that bond order means bond strength. Higher the bond order, higher will be the bond strength. And if bond strength is high, if bond strength is high, is it easy to break that bond or difficult? Obviously it will be difficult to break that bond. That means the bond energy will be high. That means the bond energy will be high, right? That means the bond energy will be high. Now see here where the bond order is increasing, that means the bond strength is increasing and that means the bond energy is increasing. We are looking for the process where the bond energy is increasing. First let's look on that. Here how many electrons? 16. 15, 12, 11, 7 or 8, 15, and here it is 14. Again 14 and here it is 13. So I think, only in one case, in this case, yes, NO to NO positive if we are going, in this case also and in almost all of these cases, in all of these cases bond order is increasing, right? Because 14, 15, right? 3, 2.5, 11, 12, same. Right? Yes. Amaya, you are just confusing yourself that sp3 and dsp2. sp3 and dsp2, that depends on the shape. sp3 tetrahedral, dsp2 is square planar. For that hybridization differ. That is shape thing. Hybridization doesn't, yeah. That's a different concept. Yes, yes. Yes, we do have dsp2, not we have sp3d actually. Okay, we have sp3d, that is for 3, 1, 4, 5. When steric number is 5, when steric number is 5, it will be sp3d. And again dsp3, simple inner orbital outer orbital concept, right? If inner orbitals are there, then dsp2 hybridization, or if outer orbitals are there, then sp3 hybridization. That's like coordination compounds, right? That depends on. Okay, clear? Yes. So here, in all of these cases, the bond order is increasing. So we can't differentiate on that basis. We need to see where the bond energy is also increasing along with paramagnetic to diamagnetic. Okay, now let's see here. This solves something. Paramagnetic, which is paramagnetic? This one, 16, 12, 14, all are diamagnetic, right? Because you can pair the electrons, right? You can pair these electrons. They are in pairs, right? Divisible by 2, even numbers, simple. So only one is odd one out, right? 15 electrons, that means there is one electron that will be unpaired. One electron will be unpaired, that means it is paramagnetic. NO is paramagnetic, okay? Now, in NO positive, there are 14 electrons, again, even number of electrons, that means it is diamagnetic, that means it is diamagnetic, okay? 1 second. Some of you are so nice here. 1 second, huh? Okay. Okay, so now listen carefully here, okay? bond order is directly proportional to bond strength, that means it is directly proportional to bond energy, right? Because if the bond is really strong, you'll need to give really high energy to break the bond, right? That means high bond energy. So in all of these cases, as you can see, the number of electrons are decreasing, and if you know the concept of bond order, if number of electrons are decreasing like this, in that case bond order will increase. So on the basis of bond order, we can't differentiate. So what we will differentiate on? We will differentiate on the basis of paramagnetic to diamagnetic. Here 15 electrons, this much electrons means that is paramagnetic, and 14 electrons means this is diamagnetic. This is diamagnetic. So the correct answer is option C. Okay, because the bond order is also increasing, 15 to 14, that means the bond order is 3, and here the bond order is 2.5, right? The bond order is also increasing, and the behavior is changing from paramagnetic to diamagnetic. Okay, so the correct answer is option C. Okay, yes. 16 electron is not paramagnetic behavior. 16 electron is not paramagnetic behavior. Simple. Para means unpaired electrons. Diamagnetic means all the electrons are being paired. If all the electrons are being paired, that means they are divisible by 2. Basic maths, divisible by 2, right? So if all of them are divisible by 2, that means you can pair them. That means you can pair them, right? I'm not going there. Okay, please. Okay. That depends on how you're filling it. Okay. Okay, just 1 second. Next question. Electronic configuration of X, it belongs to which one? X electronic configuration is, I'll write it down, 3s2, 3p1. This is aluminum, right? This is aluminum. Which group and which period it belongs to? You answer that. Which group and which period it belongs to? Which group and which period? So it belongs to aluminum, right? Aluminum belongs to 13th group and 3rd period. 3rd period. Very easy, right? You can calculate 13 electrons are there. That means it is aluminum, right? Aluminum belongs to 13th group and 3rd period. Yes, it belongs to the boron family. Yes, it belongs to the boron family. Clear? So 13th group and 3rd period. Option B. And all of you answered B. Good. Next question. Yes, 13 is... Okay, yes, good. Next question. Which one of the following pair of atomic numbers represent elements belonging to the same group? Same group. Ma'am, how do we recognize without periodic table? No, you are in PU, you are giving KCET exam, so I would assume that you know up to 1 to 30. Up to 30 atomic number you should know, right? If you know up to 30, that's more than enough, okay? So if you know that, then you know enough of the periodic table, okay? Yes. Okay. O2 has paramagnetic behavior. BTS forever, what are you talking about? You're just spamming. You can explain what question. Yes, Sagar, it is true. Ma'am, I know 1 to 20. It's okay. 21 to 30 is very easy. Scandium, titanium, vanadium, chromium, manganese, iron, cobalt, nickel, copper, zinc. I sing it like a song, it will be easy. Sahana, speed up, where you want to go, macha, where you have to find it. Answer it, na, it's very easy. Same group they are belonging. Okay, so 13 is what? Aluminum. 11 is what? Sodium. 14 is what? 13, 14, silicon, right? No, nitrogen, phosphorus. 12 is magnesium. Yes, silicon, and this is magnesium. Yes, this is magnesium. This is silicon. Okay, 20 is again calcium. Sodium, calcium do not belong to the same group because they do not have the same number of valence electrons. Okay, so that means what it is? 13 and 31. This is gallium. Yes, gallium and aluminum belong to the same group. Yes, they belong to the same group. Boron family. Yes, boron family. Correct. All of you correct. A. Yes, all of these are belong to different groups. Okay, let me go to that question. I don't know why am I even going there. So, okay fine, this is paramagnetic. Yes, O2 with 16 electrons is paramagnetic. O2 with 15 electrons, is it diamagnetic? O2 with, tell me BTS forever, is O2 with 15 electrons diamagnetic? Did you even read the question? Obviously, Sagar, we can't say that. Yeah, obviously. Okay, fine, it is paramagnetic, done. Okay, I totally agree with you. Okay, it is paramagnetic. 14 electron, O2 positive, is it diamagnetic? Is it diamagnetic? No, it's not, right? So, paramagnetic to diamagnetic, read your question properly, okay? Read your question properly. Instead of arguing with me, read your question properly, okay? Yes, 288, 1832, that is your magic number, yes. Guys, please study, okay? Please don't do that. Atomic numbers of vanadium, chromium, nickel are given, which read the question, which one of these following are expected to have the highest second ionization enthalpy? Highest second ionization enthalpy, that means the electron is going to go from a stable configuration. The first electron is easy to remove, right? The second electron will be removed from a stable configuration. Maybe it is half filled, maybe it is full filled or something, right? Yes, so tell me the answer for this also. Very easy. Why? Because we know for chromium, the electronic configuration is argon, 3d5, 4s1. The first electron is removed from this. First electron is removed from 4s. So that means the next electron will be removed from the half-filled configuration, this half-filled d orbital. Okay, and half-filled d orbital, you need to give really high energy, right? You need to give really high energy. For rest of them, the configuration doesn't change much. The second electron is normally removed from the 4s. For these three, the second electron is to be removed from 4s. Okay, so it doesn't take that much of energy. But in this, only in this case, the electron is to be removed from d5, right? Half-filled d orbital. Yes. A. Next question. Which one of the following arrangements represent the correct order of least negative to most negative electron gain enthalpy? Okay, electron gain enthalpy is a weird concept, okay? Not a weird, but kind of an opposite concept. So, electron gain enthalpy means if any atom is willing to gain electrons, if any atom is willing to gain electrons, it will release energy because it is getting stable, and stable means releasing energy, right? So, if any electron is, any atom is gaining an electron and it is releasing energy, it is getting stable, right? That is your concept of electron gain enthalpy. So, least negative to most negative. Negative means negative. Negative means the process is exothermic. Negative means the process is exothermic. Okay, most negative means so much energy is released. Most negative means highly exothermic. Highly exothermic. And which will be highly exothermic? Which needs that electron very badly, right? Highly exothermic will be the one which needs the electron very badly. Which needs the electron here? As I can tell, looking here, fluorine. It will be fluorine. So, it could be among these. Okay. Least negative. Least negative. Fluorine, oxygen, yes. Carbon, aluminum, calcium. How many of you answered D? Yes. Is it clear to you all? Yes, I have all questions if you be patient with me. Yes. Okay. So, again, least negative to most negative. Most negative means the maximum amount of energy is released. That means on adding that electron, this element was dying to have that electron. That's why it released so much energy when it gained that electron. So, that means that atom is fluorine. And which is the least? Least will be your calcium, because calcium comes in S2, right? It doesn't want to gain any electron. So, it will be least negative. Least negative means positive kind of thing. Positive means endothermic. That means to add electrons you will need to give energy. Endothermic means when you want to add electron to an element you need to give energy to it. Okay, that is endothermic. Okay. Okay, now listen, we are talking about least negative to most negative. That means in terms of electron gain enthalpy, least negative means that not much energy is released. That means either you have to give energy to add that electron, and most negative means the energy, so much energy is released when you add that electrons. That means this element needs lots of electrons. It needs electrons. Okay, if it needs electrons it will lose so much energy. Losing energy means exothermic means the sign is negative. That means most negative. So which among the following needs the electron really bad? Fluorine, highly electronegative, only one electron is needed, right? Okay, now among the rest of these, calcium, chlorine, carbon, aluminum, oxygen, calcium belongs to S2, right? Alkali, it belongs to the second group. It belongs to second group. It has S2 configuration. So its configuration is S2. When you want to add electron, you will need to give energy to it. Next electron will be added to P, right? After S it will get added to P. That means in that case you will need to give much energy to it. You need to give energy. No energy is getting released. Rather you are spending energy there. Energy is getting absorbed. So obviously it is not negative. The electron gain enthalpy will be positive for this. The electron gain enthalpy will be positive for this. Okay? Yes, alkali earth metals. Okay? Clear? So that means the least will be for calcium. Okay, and then again when you go along the period, electronegativity increases, right? Electronegativity increases, electron gain enthalpy also increases, right? Electron gain enthalpy increases means the value becomes more negative. In terms of electron gain enthalpy, the value becomes more negative. Okay. Next question. As we move from left to right in the 3D series, again, when you're moving from 3D series, I'll just write it: scandium, titanium, vanadium, chromium, manganese, iron, cobalt, nickel, copper, zinc. Okay, when you're going from here to here, 21 to 30, 21 to 30. Tell me, electropositive character increases, decreases, what happens here? So as I know, yes, as I know, when we go from 21 to 30, left to right in the 3D series, what is happening here? Two things are happening here. Effective nuclear charge is increasing, right? When we go along a period, effective nuclear charge increases. That means nuclear pull increases, right? That means nuclear pull increases. Yes? Clear? Okay, so when we go from 21 to 30, when we are moving along a period, what happens? The nuclear pull increases. Nuclear pull increases or effective nuclear charge increases means that the nucleus is holding on to those electrons really strongly. Nucleus is holding on to those outermost electrons really strongly. Okay, so what does that mean for electropositive and electronegative character? So if a nucleus is holding on to electrons really strongly, if a nucleus is holding on to electrons really strongly, what does that mean? That electron removal of that electron is very difficult. If removal is difficult, that means it is electronegative or electropositive. If removal of electron is really difficult, that means it is electronegative or electropositive? Electronegative, right? Because it is not able to lose those electrons, right? Electropositive means electron donation is easy. Electronegative means electron donation is not easy. It rather attract an electron. Okay, so when we are going from scandium to zinc, what is happening? The nuclear pull is increasing. Nucleus is holding on to those electrons really strongly, and that means in that case what happens? The electronegative character is increasing while the electropositive character is decreasing. While the electropositive character is decreasing. Okay? Yes. No. So the electropositive character decreases and the electronegative character increases. The electropositive character decreases and the electronegative character increases. Because bachas, these are metals. These are metals. They are supposed to donate electrons. They are donating electrons. But what happens here, when you go along the period, because the nuclear pull increases, due to that the electropositive character decreases and the electronegative character increases. We have added a poll. You can answer on poll also. Let me see how many of you are answering correctly. Yes. So 71% of you have answered C. That's actually very easy. Yes, this is nice. Okay, next question. Yes, opposite to character. Yes, electropositive means donation, electronegative means again electron acceptance is more. Question 9. Yeah, if you know the electronic configuration also, if you know they belong, I know these belong to the same period, electronic configuration, whatever you say, they belong to the same period. So if I'm going along the same period, electron gain enthalpy increases, electron gain enthalpy increases. Okay, yes. Next question, yes, you are ready. Next question, density is given, the mass of the solvent you need to calculate. Tell me the mass. I'll check the answer first. Tell me the mass. Molarity is given, yes. No, P block are not there. This is normal electronic configuration, that was from periodicity. Okay. Calculate it. The molarity is 3m. The molarity is 3m and the density is 1.25 gram per mole, ml. Gram per ml, that is the density. You need to tell the mass of the solvent, mass of the solvent. So let me see how many of you B, D, B, 1 second. Yes, so anyone, okay, all of the options are there. Okay, all of the options are there, don't worry. Okay, firstly, this is the density of the solution. This is the density of the solution. So what is the mass of solution? What is the mass? Density times volume. Density times volume, 1.25 times 1000. I'm assuming the solution is 1 liter. When nothing is given, I'll assume the solution is 1 liter. Okay? Yes. No, it's not there. P block is not there, Manjunath. Okay? Yes. So calculate it, very easy, right? We know the mass now. This is the mass of solution. This is the mass of solution. You have to calculate the mass of solvent. Okay, now we know the mass of solution. We know the mass of solution. We know the mass of solute. Yes, we know the mass of solute. What will be the mass of solute? Number of moles, 3 times the 58.5. Number of moles times molecular mass will give us the mass of the solute. Number of moles times, yes, number of moles, 3m. 3m means 3 moles in 1 liter, right? Whenever this thing is given, you can assume 3 moles are present in 1 liter of solution. So that means number of moles of NaCl is 3 moles. What is the molecular mass? 58.5. We know number of moles is equals to what? Given mass upon molecular mass. We need to find given mass. So again we substitute the value. N times 58.5. Yes, very easy, simple calculation. So I'll give you the answer. The mass of solvent will be 1250. This is the mass of solution, 1250, minus, if from the solution we subtract the amount of solute, we get the mass of solvent, and the amount of solute will be what? 175.5. 175.5. So that will be around what? 1074.5. 1074.5. Yes, option D is your correct answer. Yes, correct. Okay, we calculated the mass of solution, we calculated the mass of solute. If we subtract both of those, we get the mass of solvent. We get the mass of solvent. Good. Okay, next question. Yes, this is nice. Yeah, I like this space. Number of atoms that are present in 560 centimeter cube of oxygen at STP. So for me, I know that at STP, when you have 22,400 centimeter cube, when you have 22,400 centimeter cube of oxygen, it has around Avogadro number of atoms. It has around Avogadro number of atoms. Now, the number of atoms are being asked for 560 centimeter cube. 560. Simple maths. 1, I'll just write it. So, it will be 560 by 22,400 times 6.022 times 10 raised to power 23. And if you calculate it 1 by 40, yes, it will come out 1 by 40. 1 by 40. So for this, how many of you answered B? Let me check. So it's still, you guys are still in doubt. D, how D? 1 second. Yes, so 52%, 55%. Yeah, it's more than 50%. So we agree that this is the answer. Why? Because we know at STP this much volume of oxygen have this much number of atoms, Avogadro number of atoms. We are given 560 centimeter cube. We are given 560 centimeter cube. So in that unitary method, Unitary method, yes, right? 560 by 6.022 by 22,400 times 560. Yes. Yes, at STP, okay, you don't focus on the unit typing. So 22.4 liter, right? We are talking about centimeter cube, so that will be 22,400 centimeter cube. The unit is important. The answer is given in centimeter cube. Okay? Okay. Ma'am, please correct your pronunciation. Alina, I can't go back to school now. Huh? I already have that for so long. Okay. Wow. You guys are brutal, huh? Anyways, next question. A 150 watt bulb emits a wavelength of 6600 angstrom and only 8% of the energy is emitted as light. So if it is 150 watt and only 8% is getting emitted, so how much power is getting emitted from this bulb? How much power is getting emitted from this bulb? 150, 8% of 150, that will be around how much? 12 watt. Okay, we need to calculate the number of photons. So number of photons will be how much power is getting emitted upon the total energy. What is the energy? According to Planck, what is the energy? What is the energy? That is h nu, right? H nu or hc by lambda, because we are given lambda, wavelength is given to us. H is Planck constant. So I'll just substitute all the values and calculate the number of photons. The effective power is 12 watt by H C lambda. Lambda is 6.6 times 10 raised to power minus 7. 7, 10, yes, 7. So very easy, the answer is straight 3, 4 times 10 raised to power 19. 4 times 10 raised to power 19. So how many of you answered? It's going. Some of you are calculating. Yes, Janardhan, right? The PDF will be shared. There is a WhatsApp channel link in the description of this video. WhatsApp channel link. This PDF will be uploaded after this class ends. Okay? This PDF will be uploaded there. You can practice the questions there. Okay? Yes. But I can directly solve questions from these videos. Yes, that's actually nice. So if you can solve the question, that means you have the knowledge, right? I don't know where you are getting stuck then. Okay, the center studied 11th. Do I still have time, guys? You have a lot of time. Okay, so how many questions? Yes, A. Correct answer is A. Next question. An electron having spin quantum number this. From spin quantum number you can't have an idea, but from magnetic quantum number you can have an idea. Okay? From magnetic quantum number you can have an idea. What? That you have what? N, L, M, S. N can have a value from 1, 2, 3 up to N. Okay. L can have a value from 0 to N minus 1. 0 to N minus 1. M can have a value from minus L to plus L including 0. Okay. S can have only two values plus minus half. S can have only two values plus minus half. Okay, this is just a revision. Now tell me what is the orbital involved. What is the orbital involved? Yes. Okay, for question number 14, what is the orbital involved? Very easy, right? M is 3, minus 3. As I told you, M can have a value from minus L to plus L including 0. So that means L is 3. That means L is 3. For L, we have one more criteria. What? If S orbital is there, P, D or F, what are the values of L? 0, 1, 2, 3. So that means 3 means which orbital is there? F orbital is there. We don't know the principal quantum number, so we can't tell the exact orbital 3D, 3F, 4F, whatever is there. But we know that the orbital involved is F. We know the orbital involved is F. So how many of you answered C? Let me check. How many of you? So 46% of you answered C, 47, yes, okay. Okay, done, yes. C. Yes, correct answer is C. Why? Because whenever we're talking about 4 type of principal quantum number are there, N, L, M, S. N can have a value from 1 to N, L can have a value from 0 to N minus 1, M can have a value from minus L to plus L including 0, and S will have 2 values plus minus half. So obviously S will not tell us much. What will tell us? M. M have value from minus L to plus L. That means 3 is there. L value is 3. If L is 3, then we know for S the value is 0, P 1, D 2, F 3. That means the orbital involved is F orbital. Okay? Done? Okay. Next question. Okay. For an adiabatic change, what is 0? Okay, so easy. You also tell me for isothermal. Okay, I'll just add on. For isothermal change, what is 0? For an adiabatic change, what is 0? Whenever an adiabatic process is happening, there is no exchange of heat between the system and surrounding. There is no exchange of heat between the system and surrounding. So that means it's very easy actually. Yes. Yes. A, no, not A. Work is not there. Okay. So for an adiabatic process, the change in heat is 0. The heat is 0 actually, not change. The heat is 0. Okay. For isothermal change, yes. For isothermal change, one other thing is there. Change in internal energy is 0 because the temperature is constant for an isothermal process. As the temperature is constant, the change in internal energy is 0. If the change in internal energy is 0, then according to first law of thermodynamics, delta U is equals to Q plus W. The change in internal energy can be brought by change in heat or by doing work. By changing heat or by doing work. Okay. If this is 0, if this thing is 0, that means Q will be equals to negative of W. That is for isothermal process. For adiabatic process, Q is equals to 0. If Q is equals to 0, then that means change in internal energy will be equal to work. So whatever work you are doing, that is being used to bring change in the internal energy. Whatever work you are doing, that is completely utilized to bring change in the internal energy. Okay. So how many of you answered D? Let me check. Oh, nice. 80% of you answered D. Good. Okay. Yes. Next question. Yes. Move on to the next question. The temperature of 1 mole of an ideal gas increases from 298 Kelvin when it absorbs 200 joule of heat at constant volume. Change in internal energy. This is a tricky question. Okay. Listen. Have I misread it once again? Okay. Change in internal energy you have to tell. Heat is absorbed. When heat is absorbed, is it positive or negative? So whenever heat is absorbed by the system, it is positive. Whenever heat is released by the system, it is negative. So that is plus 200 joule. Okay. At constant volume, the process is happening at constant volume. The process is happening at constant volume, guys. So we know when the process is happening at constant volume, that means it is, what is 0? Work is 0, right? Work is minus PdV. And if the volume is constant, then the work done is 0. If the work done is 0, what does it tells you about the internal energy? If work done is 0, according to first law of thermodynamics, change in internal energy is equals to heat plus work. Work is 0. That means your internal energy is equals to the heat. Whatever be the heat absorbed or released by the system, it is directly equal to that. So change in internal energy is equals to plus 200 joule. Okay, let's see how many of you. 68. Okay, done. 71% people. Okay, good people. Yes. Good morning, Pallavi. Good morning. I remember your birthday was in the last life. Okay, yes. No. Okay, clear? Yes. So we move on to the next question. Done? The pH of a mixture. You are given this. You need to tell the pH of the mixture. Okay, now see. We are given H2SO4, HCl and calcium hydroxide. These two are acids and this is a base. So that means there is some neutralization also happen, right? There will be some neutralization happen, and at the end, whichever ion is left, whether it is H positive or it is OH negative, on the basis of that you will calculate the pH, right? Because acid base is there, there will be some neutralization happening, right? Now let's calculate how much acid and base we have here. We have 0.1, 10 ml of 0.1 m H2SO4. Okay, 10 ml of 0.1 m H2SO4. How many H positive are there in H2SO4? 2H positive, right? So that means it will provide 2H positive. So what are the moles, equivalent moles of H2SO4? So equivalent moles means, so if you have, let's say in 1 liter you have 4 mole equivalent, 4 milli equivalent of H2SO4. If you have in 1 liter 4 milli equivalent, so it will be like that, 100 molecule of water, you will have 100 molecule of water. In that 4 molecules of H2SO4 will be there. It's like that. Okay, so that means there will be 4H positive. Okay, so it's directly related to concentration. I'll tell you how. We calculate the milli equivalent. How do we calculate? So we calculate the milli equivalent by multiplying the volume. H2SO4 has 10 liter, right? 10 ml, right? 10 ml, and how much concentration of H2SO4? We have 0.1. Now 1 H2SO4 is providing 2H positive, right? So the milli equivalent will be how much? No, it's only 2 milli equivalent. Okay. For HCl, we have how much HCl? 5 ml of HCl having 0.2 m concentration. Again, how much H positive we have? Only one. Okay, so this will be 1 milli equivalent. Okay, so H2SO4 is providing 2 milli equivalent of H positive. HCl is providing 1 milli equivalent of H positive. OH negative. How much OH negative is being provided by calcium hydroxide? So that will be your 5 times 0.1. How many OH it can give? 2, right? It can give 2. So that means again 2. Yes, 5 times 2. Yes. So in general, how milli equivalent you will have? How much milli equivalent? 2 milli equivalent of OH negative. 2 milli equivalent of OH negative and 3 milli equivalent of H positive. So H positive is around 3 milli equivalent, OH negative is around 2 milli equivalent. So after neutralization, these 2 H positive, 2 OH negative will react, 1 H positive will be left. What is the H positive left? 1 milli equivalent. Now this is milli equivalent. We don't know the concentration. How do you calculate the concentration? Milli equivalent by the volume, total volume of the solution is how much? 10 plus 5 plus 5, which is 20. So that is 1 by 20. 1 by 20. Did I do something? 1 second, let me check. 2 milli equivalent. Okay. 5 times 0.2. Oh, no. I did here wrong. It's 1 milli equivalent, right? Yes. 1 milli equivalent, that means 1 milli equivalent of OH negative is there, right? And if 1 milli equivalent is there, that means you have 2 milli equivalent here and 2 by 20. 0.1. The concentration is 0.1. Yes, the concentration is 0.1. Sorry, I mistook this calculation. Okay, 0. Yes, the concentration of H positive. The concentration of H positive is 0.1. So again, pH is what? Negative logarithm of H positive. Negative logarithm of 0.1. So that will come around 1 only. How many of you answered A? Let me check. 50%. You guys are still in doubt? 50%. The percentage decreased, huh? Okay. Yes. So the correct answer is negative logarithm of 0.1, that is 1. Okay. Clear? So pH will be 1. Firstly, we calculated the amount of H positive. We calculated the amount of OH negative. How we calculated? This much ml and this much concentration. 10 ml of H2SO4 of 0.1 concentration, right? How much H positive it can provide? 2.
right? So that is the milli equivalent concentration of H positive. Similarly, for HCl we calculated, then we calculated for OH negative for the using the same process. Now neutralization will happen. 3 milli equivalent of H positive will react with 1 milli equivalent of OH negative. What will be left with? We will be left with 2 milli equivalent of H positive. We will be left with 2 milli equivalent of H positive. 2 milli equivalent means how much concentration? What is the total volume? 20 ml, right? 10 plus 5 plus 5, 20 ml. 2 by 20 means 0.1 m concentration. The concentration is 0.1 m. If the concentration is 0.1 m, so my negative logarithm of 0.1, that means the pH is 1. That means the pH is 1. Damn good. Actually, you should be proud of yourself if you're solving them on your own. Okay? Okay. Next question. For this equilibrium, firstly you should, I'll write the relation, till then you answer this question, okay? I'll write the relation, you guys answer this question. The relation between Kp and Kc is this. Kp equals to Kc RT raised to power delta Ng. What is delta Ng? Delta Ng, again, it is the number of gaseous molecule of product, number of gaseous molecules of product minus number of gaseous molecules of reactant. Number of gaseous molecule of reactant. So tell me, reactant, how much? This delta Ng value you need to tell me. This delta Ng value you need to tell me. So how much gaseous product we have? 2. How much gaseous reactant we have? 2 plus 1, 3. So 2 minus 3. Delta Ng will be minus 1. Delta Ng will be minus 1. Yes? Yes, delta Ng will be minus 1. So Kp will be equals to Kc RT raised to power minus 1. So it can be written as, yes, B. Good. Yes, it can be written as Kp equals to Kc by RT. Kp equals to Kc by RT. Yes. Good? Yes. Going good, guys? Yes, all of you are answering correctly. Good. Next question. Yes, next question. Choose the correct statement applicable for this reaction. What is happening here? Tell me. What is happening here? H2O, F2, HF, O2. Simple, very easy. Simple, very, very easy. Yes, poll is coming. Brain corner, try, like, wait. Some person is handling it. Let her be, okay? They will handle it, okay? It'll come in the next question, okay? Don't worry. Very, very, very easy. Yes. H2O. So you can check on the basis of oxidation state also. 0 to minus 1 it is going. 0 to minus 1. That means this is undergoing reduction. This is undergoing reduction. That means this will be undergoing oxidation, right? If one is undergoing reduction, the other will be going oxidation because it is a redox reaction. Okay, so what is happening here? Okay, what is happening here? Water is getting oxidized to O2, correct? Water is getting oxidized to O2. F2 is getting oxidized? No. F2 is getting reduced. Water is getting reduced? No. F2 acts as reducing agent? No. Reducing agent means it is oxidizing itself. It is not oxidizing itself. F2 is getting converted into HF. F2 is getting reduced. So it will be a oxidizing agent. This will be a oxidizing agent, not a reducing agent. So quickly answer the poll now. I'll check. If this one comes, yes, still 1%, 91. Okay, good. 91, good. Good. Next question. Yes, A. Yeah, guys, don't chat here. Yeah, it's a revision class. Don't do that. Okay. Next question. Yes. The oxidation number of chromium in potassium chromate. What is the oxidation number of chromium in potassium chromate? What is potassium chromate? I'll tell you. K2CrO4. That is potassium chromate. Only one chromium is there. Potassium dichromate, K2Cr2O7. 2 chromium is there. So that is potassium dichromate. Okay. But we are talking about potassium chromate. So this is your potassium chromate. Tell me the oxidation state of chromium. Oxidation state of chromium, very easy. Yes. Plus 6. Plus 6. Plus 6. Yes. So answer correctly. So how many of you? Some questions I still get confused. I don't know why. You guys show some questions are straightforward, factual or something, and then I'll be expecting 100%, but still there will be 2-3% kids answering this. Okay. Okay. Done? Yes. So for D, you got 67%. Done. Okay. 67 I'm fine with. Like as long as it's more than 50. 68 also. Okay. Ma'am, can you show how to find it? Very easy. So for potassium, the oxidation state for potassium is +1. For oxygen is -2, right? How many potassiums are there? 2. So +2 plus, I don't know for chromium, so I'll take it as X, okay? For oxygen, plus -2. How many oxygens are there? 4 oxygens times 4. How much charge? On this whole compound, how much is the charge? There is no charge, okay? Here it is 0. If nothing is written here, that means the charge is normally written here. If nothing is written here, that means the charge is 0. So just check here, X +2 -8 +2 -8, that means -6 equals to 0, equals to 0. That means the oxidation state is +6, okay? Some you need to know, for example, for hydrogen, for oxygen, for any alkali metal, sodium, potassium, they have +1 oxidation state, -2, +1, clear? Only some you need to know, rest will be given and all, okay? Done. Yes, 2 + x - 8 equals to 0. Done. Yes, beat us Telugu forever. Please tell my name, Divya. Okay, is it okay now, Divya? Okay. Next question. When 2-bromopentane is heated with alcoholic solution of potassium hydroxide, the major product is. I'll draw the 2-bromopentane first. 2-bromo. 1, 2, 3, 4. 3, 4, 5. Okay, if you treat it with alcoholic potassium hydroxide, firstly, the reaction is elimination. Why? Because see, ene and ine, that means alkene and alkyne are forming. So obviously elimination will happen. Now there are 2 products possible, right? The elimination can happen from this carbon or from this carbon. From which carbon the elimination will happen? Carbon 1 or carbon 2? That is decided by a rule called Setzeff rule. Okay? What is that Setzeff rule? So whenever we are talking about elimination, whenever we talk about any elimination reaction, so the major product, in that case, the major product of elimination reaction, the major product will be the more substituted alkene. And what do you mean by the more substituted alkene? More substituted means the more number of alkyl groups will be attached. More number of alkyl groups will be attached to that particular alkene. Okay, now see, if we remove the hydrogen from one, what will happen? CH2, double bond CH, CH2. Right? So here, to this carbon, only 2 hydrogens are there. There is no alkyl group. Here, only 1 hydrogen and 1 alkyl group is there. With this carbon number 2, this carbon, only 1 hydrogen and 1 alkyl group is there. So this is only 1 mono substituted. Only 1 alkyl group means mono substituted. But if I remove the hydrogen from this one carbon, let's see. In that case, what will happen? So it will be CH, double bond, CH, 1, 2, 3, 4, done, CH3. So in that case, let's look at this alkene, this carbon and this carbon. On carbon 1, look at the carbon 1, it has 1 alkyl group. On carbon 2, it also has 1 alkyl group, CH2, CH3. Okay, this carbon also has 1 alkyl group, this carbon also has 1 alkyl group. That means it is di-substituted. That means this is di-substituted. Okay. The first one was mono-substituted. Second one is di-substituted. Obviously, di is more substituted, right? 2 alkyl groups are there. Okay. So the product will be pent-2-ene. How many of you answered B? Let me check. In this one, I don't know. My vote is not coming. Oh, yo, that's actually nice. Oh, most of you agree. Good. Yes, Ajay. Is your name Ajay? Are you okay? Say my name, ma'am. Okay, done. Clear? Pent-2-ene. Using Setzeff rule. Okay, Setzeff rule is used only in case of elimination. There is one more rule, Markovnikov rule, that is used for addition. Markovnikov rule is used for addition. Setzeff rule is used for elimination. Setzeff rule is used for elimination. Okay, just write it down somewhere just to simplify it. Okay, next question. Which of the following chemical system is non-aromatic? Non-aromatic. We have aromatic, we have anti-aromatic, we have non-aromatic. So non-aromatic follows some criteria. What are those criteria? Non-aromatic are non-cyclic, they are non-planar, Okay, what else is there? They are non-cyclic, yes, they are non-planar, and they do not follow that pi electron rules also. Okay, they have a sp3 carbon. They have a sp3 carbon in between two sp2 or sp carbons. They have a sp3 carbon in between two sp2 or sp3 carbons. Okay, sorry, sp2 or sp carbons. Here it will be sp2 or sp, and in between that there will be an sp3 carbon. Okay, okay, they are cyclic. They are cyclic. They are not cyclic. They are non-planar. They are non-conjugated also. So very easy. We can see one straight away. All of them are aromatic except this one. Except this one. Why? Because there is a sp3 carbon in between two sp2 carbons. sp3 carbon between two sp2 carbons. There is no conjugation. Also, no conjugation. So the correct answer is option D. And how many of you answered D? The poll is gone. 52% of you answered D. Good. Okay, next question. 22. Okay. This one, in which of the following reaction product P will not give? Firstly, you should know what is product P. This is hydration of alkynes. Hydration of alkynes. It gives what? Aldehydes. It gives aldehydes. Which aldehyde we will get? Acetaldehyde. We will get acetaldehyde. This is the aldehyde. Now, Tollens test is given by aldehydes. Yes. Brady's test, 2,4-DNP test, 2,4-DNP test. It is also given by carbonyl compounds. It is also given by carbonyl compounds. So correct. Okay. Victor-Meyer test and iodoform test. For iodoform test, the group is CH3CO. Is this group here? CH3CO. Yes, the group is there. Okay. For Victor-Meyer test, that is different. Victor-Meyer test is given by alcohols. It is given by alcohols. Okay. Victor-Meyer test is given by alcohols. Obviously, this will not be, these are different questions. Yes, Victor-Meyer test is used to distinguish alcohols. So, it is a test which is given by alcohols, primary alcohol, secondary alcohol, tertiary alcohol. Primary alcohols gives red color, secondary alcohols give blue color, and tertiary alcohol will be colorless when they are treated with Victor-Meyer reagent. It's a long reagent there. Okay? Yes. So, which among the following, the product P will not give which test? Since the product P is an aldehyde, it will not give the test for, alcohols. Okay? So, that is your answer C. Option C. Okay? Yes. 44, 45. Good. Clear? Done? Yes. I'm not answering first. I'm just telling you the answer. I told you acetaldehyde. Then I waited for your response. Then I saw C. That's why I answered that. It is Victor-Meyer test. Okay? Done? Okay. Next question. The organic compound obtained during the addition of HBr to propene in the presence of peroxide catalyst. So again, addition is happening. I'll just tell you the rule to give you a hint. The rule will be applied anti-Markovnikov rule. Anti-Markovnikov addition will be there. So just tell me the product. Anti-Markovnikov rule will be there because peroxide is there. Okay. During the addition of HBr to propene, if we add HBr to propene in presence of peroxide, okay, H2O2 I can write peroxide. Okay. Yes, Hoffman rule for bulky bases and anti-Marconi for peroxide. Yes, correct, Adi. Okay, tell me. I'm not answering. See, I'm controlling myself really hard this time. Okay. Yes. 24. So 24 will be yes. Good. Are you voting? Yes. Let me see your votes. Yes. Good. Yes. Good. Now I can answer, right? Now I can answer. Am I allowed to answer now? Now listen. Again, when you treat this with HBr, propene to propene, again you have two possibilities. The Br can add here also and Br can add here also. So Br will add onto which carbon? That depends on the peroxide. If peroxide is there, less substituted, it will attack, the Br will add to the less substituted carbon. Less substituted, okay? If peroxide was not there, Br would attack the more substituted carbon. Which is more substituted? This one alkyl group. This has only 2 hydrogens, right? So again, in presence of peroxide, Br will attack, or the nucleophile will add onto the carbon which is less substituted. So the product in this case will be CH3, CH2, CH2, Br, 1-bromopropane, 1-bromopropane. Okay, and all of you agree to option C? Yes. Good? Okay. Done? Yes, correct answer is option C. Good. Next question. Okay. Markovnikov rule is applicable to. Now again, remember, Markovnikov rule, that means it is sort of an addition. You need an alkene. You need an alkene plus a reagent. Normally, which reagent we use? HBr. So remember, Markovnikov rule is only applicable when you have an unsymmetrical alkene, and a unsymmetrical reagent, right? Because only in that case you have two possibilities. At the less substituted position, let me just go back to this one. So this hydrogen will attack on the more substituted carbon. This bromine will attack on the less substituted carbon, right? So again, this should be unsymmetrical. If both were bromine, Br, then in that case the product will be kind of a vicinal dihalides, right? Vicinal dihalide, right? Both will have bromine, equal possibilities. Okay, so again, you should have an unsymmetrical reagent and an unsymmetrical alkene. Now tell me, so that means this is out. Okay, these three are there. C2H4, ethene, it is symmetrical. C2H4, again ethene, symmetrical. Both are equal position. So that means only one is correct, that is option A. And by this time you should have answered. 91 votes are there for A. That is very good. 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 Okay. Okay. Done. Okay, yes. So the alkene should be unsymmetrical because only then you will have two possibilities, right? Only then you will have one less substituted position and one more substituted position. And your reagent should also be unsymmetrical because only in that case you can differentiate that on the less substituted hydrogen will go or on the more substituted bromine or halide will go. Okay? Just remember it. Okay? Okay, next question. The IUPAC name of tertiary butyl chloride. Ayo, it's very easy. Tertiary butyl chloride. This is tertiary butyl chloride. Tell me the name of this compound. This is the name. This is the structure of tertiary butyl chloride. Tell me the name of the compound. Yo, that was nice actually, Samrat. Yes. No, it's okay though. Tell me the name of the compound. Okay. I'll have some sip of water till then you guys tell me. Very easy. 1, 2, 3, right? Yes, so 1, 2, 3. At 2 we have chloro and at 2 we have methyl. So C will come first. So 2 chloro, 2 methyl propane. Pole gone kya? Okay. Pole is gone. 2 chloro, 2 methyl propane. I saw your answers, everybody. Yeah, I saw your answer. Okay. Yes. Gone. The pole will come. Trust me, the pole will come. Okay, next question. Arrange the following in increasing order of stability. Increasing order of stability. Increasing order of stability. Okay. So, increasing order of stability. Here, can I give you a hint, guys, so that you can answer easily? 1 second. So, I'll give you a hint. In this case, the concept that is used is hyperconjugation. Hyperconjugation. Oh, what is that, ma'am? We got scared from hyperconjugation. So, hyperconjugation is a very easy concept. So, in hyperconjugation, if you have a unsaturated system close to a saturated system, okay, close to a CH sigma bond, probably CH sigma bond, then this bond gets donated, this electron pair gets donated, right? Kind of a no bond resonance thing happen, okay, and this electron pair get donated to the nearby unsaturated system system, or you can say empty p orbital, okay, or to the unsaturated system, or to the empty p orbital. That is the simple concept for hyperconjugation. So just see how many hyperconjugation structures are possible. Let's see. No, this one doesn't need hyperconjugation. No, there will be. So that is equals to what? Number of alpha hydrogens. That depends on the number of alpha hydrogens. So check the number of alpha hydrogens here. In this case, you will have how many? 6 plus 2. 3 times 2, 6 plus 2, that means 8 alpha hydrogens are there. Okay, now here you have 3 times 3, which is 9 alpha hydrogens here. Okay, here how much you have? 6 alpha hydrogens are here. Here you have 3 alpha hydrogens, and here you have 0 alpha hydrogens. Alpha hydrogen, you know, right? The carbon, that is, one second. The carbon, 8, 9, 3, 0, 6. So alpha hydrogen means the carbon that is directly connected to the functional group, that is alpha carbon, right? And the carbon that is associated, and the hydrogen that are associated with that carbon are your alpha hydrogens. Okay, so more the number of alpha hydrogens. Hyperconjugation is shown by what? Alpha hydrogens, right? You have an unsaturated system or an empty p orbital, and to that empty p orbital you have these hydrogens, these alpha hydrogens attached, right? Now these alpha hydrogens will fulfill this electron density, will donate this electron density to this empty p orbital, okay, to this empty p orbital, okay. So what will happen then? Empty p orbital, no bond, resonance, this electron density is getting fulfilled, more stability. One time this can donate, second time this can donate, third time this can donate, so many resonance happen, right? Yes, so the pole was there. I missed the pole. Did I miss the pole? No, the pole is here. Tell me. This will have the least, I know. So let's look at 5, either this option or this option. Which will have the most maximum number of alpha hydrogens are there in 2. So 2, yeah, this is your correct answer. Option A. Now let's see how many of you answered A. 73%, that's actually very nice. Good. Hyperconjugation is directly proportional to alpha hydrogen. Yes, more the number of alpha hydrogen, more will be hyperconjugating structures. Okay. Done? Yes. Good one. Good. Next question, shall we? Yes. What is the hybridization state of benzyl carbonium ion? Tell me the hybridization of benzyl carbonium ion. Again, here you use your concept, number of sigma bonds plus number of lone pair. How many sigma bonds are there? 2, 1. 2 hydrogens, 1 with this other carbon, so 3. What is the hybridization? The steric number is 3. Hybridization will be sp2. Please answer A. Yes. A. We are faster than our poles, huh? Before our pole come, we can answer. Yes, A. Good. Correct, Amaya, Parikshat. Okay, GS, Suni. So many of you are answering correctly. Good. Okay, next question. Number of sigma bonds plus number of lone pair. Sigma bonds is how much? This carbon has 2 hydrogens and with this other carbon, right? Yes. Next question. Nitrogen detection in an organic compound is carried by Lassagn's test. So the blue color formed correspond to which of the following formula? So when we do Lassagne test, firstly we add sodium, we make a sodium fusion extract, right? What do? We add sodium in presence of this carbon is there, nitrogen is there, NaCN is formed, right? Okay, now after that what happens? NaCN is formed, after that what happens? I'm writing the reaction, till then you answer, okay? NaCN, right? Now this is treated with FeSO4. Freshly prepared iron sulfate solution. This NaCN, this sodium extract you prepared, that is treated with freshly prepared iron sulfate. Yes, that is prepared by that is treated with freshly prepared iron sulfate solution. What happens there? You get hexacyanoferrate, which is Na4 FeCN6, hexacyanoferrate. This is the compound that gets formed. Now after that what you do? You treat it with FeCl3 in presence of concentrated HCl. You treat it with FeCl3 in presence of concentrated HCl. Okay, then you get what color? You get a Persian blue color. Persian blue color compound is formed. What is that Persian blue color compound? That is your ferricyanide. Ferricyanide. Remember the name? Ferricyanide. 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 Okay. Yeah, I'll explain. Don't worry. Okay. Ferricyanide. Okay. So that is Fe4. FeCN6 whole thrice. Clear? Fe4 FeCN6 whole thrice. Fe4 FeCN6 whole thrice. That is option B. Now let me check how many of you answered option B. 43. Ayo, most of you are confused or something. One second. Equal. My God, there is a competition between A and B. Okay. So what is happening here? When we do detection of nitrogen in an organic compound, we make sodium extract first. What is a sodium extract? So we have the organic compound, we boil sodium, right? We heat the sodium and then we add a little compound on top of it. We fuse sodium with it. What is happening there? Sodium plus carbon plus nitrogen is there, combined to form sodium cyanide. Sodium cyanide. This is the compound that we form by doing that soda extract process, right? That sodium extract that we are preparing, that is sodium cyanide. Okay. When it is treated with a freshly prepared solution of iron sulfate, it gets converted into this compound, that is your hexacyanoferrate. Okay. Now this compound, when it is treated with FeCl3 in presence of concentrated HCl, it gets converted into ferricyanide, which gives a Persian blue color. If Persian blue color is there, that means nitrogen is there. Okay, it tells clear indication for, it is a clear indication for nitrogen, the Persian blue color. What is that compound? That is ferricyanide. Ferricyanide. Okay, is it clear? This is practical question. I know practical questions are of a problem for you all. Don't worry, we are working on it. We'll bring something for it. Okay, don't worry. For practical questions also we'll bring. Okay, so for question number 29, again the answer is option B, and let me check, 90% of you answered B this time. Okay, good. Actually good class. Okay, next question. Okay, next question. Identify the electrophile. Electrophile are species that are electron deficient. So obviously this is not the case. This is not the case because it is negative. It already have extra electrons. Okay, now let's see here. NH2, aniline, right? It's kind of amine, right? Amine, it has electrons. And nitrogen has electrons. It can donate these electrons. So obviously it is not an electrophile. NH3 also has a lone pair of electrons. Ammonia also have a lone pair of electrons. It can also donate these electrons. So obviously this is not an electrophile. An electrophile is a electron deficient species. An electrophile is a electron deficient species. So which is electron deficient here? This. C. Yes. C. Good. Correct. Why C? Again, because this is a Lewis acid. Lewis acid. What are Lewis acids? Lewis acids are electron acceptors. Electron pair acceptors. Lewis acids are electron pair acceptors. Clear? Electron pair acceptors means they have electron. They are electron deficient. Only then they will accept electrons, right? If I am poor, only then I'll accept money, right? Which I am. Okay. So next question. No, I'm not. Okay, sorry. Next question. Which one of the following statements is not correct? Incorrect statement you need to tell me. Okay, increase in pressure will incorrect. Okay, listen, not correct. That means we are looking for incorrect statement. Increase in pressure will increase the solubility of gas in liquid. Yes, it does, because solubility, as far as I know, solubility is directly proportional to pressure and inversely proportional to temperature. Solubility is yes, solubility is answer. I'm waiting for your answer. Solubility is directly proportional to pressure and inversely proportional to temperature. So if you increase the pressure, the solubility of gases increase. At high pressure, the number of gas molecule per unit volume over solution increases. That is same. This means solubility. This is solubility. Fancy name for solubility. Dynamic equilibrium exists between the molecule in the vapor and in the solution. Dynamic equilibrium. Dynamic means the equilibrium is not static. Dynamic. Dynamic means some vapor molecules, solution and there is vapors, right? So some vapor molecules are getting converted into solution. are going in the solution, and from solution some solution particle are getting converted into vapor. So there is a dynamic equilibrium. The process is happening, but still there is an equilibrium. That is the definition of dynamic equilibrium, that the system is at equilibrium but the process is still ongoing. The process is still ongoing. Okay, yes, so the correct answer is D, because at high pressure solubility of gas decreases. Nope, because at high pressure solubility of gas increases. Solubility of gas increases until it reaches an equilibrium state. It does not decrease. So all of you which are answering D, which I see, okay, okay, good, yes. Yes, yes, good, good. Next question, shall we? Okay, next question. We have a long way to go, but you guys are doing really good today. Okay, I'm proud of all of you. I'm proud of all of us actually. A gas X is dissolved in water at 2 bar pressure. Mole fraction is given. Mole fraction of water we need to double the temperature we need to tell. Okay, solve this question. Solve this question. So 2 bar pressure, okay, its mole fraction is 0.02. So for gas A, 2 bar pressure and the mole fraction is 0.02. The mole fraction of water when the pressure of gas is doubled at the same temperature. So as far as I know, the pressure of gas is directly proportional to mole fraction of that gas. The pressure of gas is directly proportional to mole fraction of that gas, right? So if you double the pressure, then your mole fraction will also double. Then your mole fraction will also double, right? Now the new pressure is 2p, so your mole fraction will be 2 times of 0.02, which is 0.04. This is the new mole fraction. This is the new mole fraction of gas. This is the new mole fraction of gas. Now what is the mole fraction of water? Very easy, 1 minus mole fraction of gas. 1 minus mole fraction of gas. So 1 minus 0.04, that is 0.96. Simple. Henry's law, right? Henry's law. Pressure, partial pressure of gas is directly proportional to mole fraction of that gas, right? Directly proportional. If we double the pressure, mole fraction will also double, right? If mole fraction is doubled, that means this is the new mole fraction of gas. So what is the mole fraction of water? 1 minus the mole fraction of gas. Some questions are too easy, huh? So let me check how many of you answered this correctly. This is for 31. The question is 32. Okay, no worries. I'll check. That is a different vote. Poll. C. Yes, C. All of you are answering correctly. C. Next question. The composition of azeotropic mixture of ethanol and water. Okay, I'll give you a little revision thing. Okay, listen. Azeotropes are your constant boiling mixtures. That means they have water, they have liquid and they have vapors. They have liquid and they have vapor. They are in a sort of a perfect composition where they do not boil off at a constant temperature. They boil off at a constant temperature. Okay, so we have mixture. It is a mixture of two components. Okay, that boil off at a constant temperature. Boil off at a constant temperature. At a constant temperature. Now we know in Raoult's law there are two types of deviation, positive deviation and negative deviation. If you have positive deviation from Raoult's law, so the components that are showing positive deviation from Raoult's law, they make minimum boiling azeotropes. They make minimum boiling azeotropes. And if negative deviation from Raoult's law is shown, so we get maximum boiling azeotropes. In that case, we get maximum boiling azeotropes. Okay, so here one combination is there which is very easy. Yes, 95% ethanol and 5% water. That is, what kind of azeotrope is this? Minimum boiling or maximum boiling? Tell me, minimum boiling or maximum boiling? I am waiting. Minimum boiling or maximum boiling? Yes. So ethanol and water show positive deviation, so they will make a positive deviation, means they will make a minimum boiling azeotrope. Yes, minimum. All of you, good, correct. Yes, see, good. So poll came, answer now. Okay, it's okay. You can answer now also. Yes, B. Still, C and D also. Huh? You're just testing that thing called patience. Okay, next question. Yes. Okay. A 5.25% solution of a substance isotonic with 1.5% solution, same destinated. Molar mass you need to tell. Molar mass you need to tell. So this is isotonic with this. Isotonic means same osmotic pressure. So same osmotic pressure means pi 1 equals to pi 2. That means C1 equals to C2. C1 equals to C2. Density is same. Density is same. If the density is same, I can assume this is the amount given to me. I can assume this is the amount given to me. That is the weight by weight percentage. I can assume it, right? Weight by volume percentage also. I can assume it weight by volume percentage. And weight by volume is normally what? Molarity or concentration, right? Concentration is mass per unit volume, right? Okay. So 5.25 by this solutions, this substance molarity, this substance molecular mass I don't know. It should be equal to the molecular mass, sorry, it should be equal to the concentration of urea, 60, 5.25. You can solve it. Can you solve it? It's very easy, right? 5.25, 1.5 by 60, done. So that will be 40. The answer is around how much? C, yes, 210. It will come around 210. Yes, it is 210 grams. 210 grams. Because the density is same, we can just assume that the percentage that is given is directly the weight of the solute. The weight of the solute that is dissolved. It's directly assume, we can directly assume that, or we can believe that this is the amount of solute that is dissolved in solution. Okay. Yes, so the correct answer is option C, and let me see how many of you answered C. Yes, 62%, good. Okay, as long as it's above 50, I'm happy. Okay. Okay, C, good. Again, Likhit, the PDF will be provided once this class ends on the WhatsApp channel. The link is in the description of this live. Please go check it out, okay? And there you can join the channel, and there the PDFs are uploaded after each and every class, okay? Don't worry. This will be uploaded, don't worry. Next question. In fuel cells, which are used as catalyst? In fuel cell, which catalysts are being used? Which of the following is used as catalyst? Answer this question. Oh my god, you are studying from me, you don't know my name? Okay, sorry. Hi everyone. Ayo, the answer is simple actually. In fuel cells we use which one as catalyst? Let's see the poll. Some of you are answering C, D, B. Okay, so the correct answer is B, platinum palladium. Yes, the correct answer is B, and there are 70 votes, 43, 40, 39. Let's go above 50%. Okay. Yes. Next question. 105. Let me check. 46. Almost there. 46. No. Nickel cadmium is different. It is used in other batteries. Acid batteries we use it normally. Lead manganese acid batteries. This is lithium ion batteries we use it. Okay. No break. 50 question we'll do. Then we'll think about break. This not even lunch time yet. I am not even hungry. Are you not enjoying the class, girl? Next question. Okay. What will happen if we add more H positive? If we add more H positive, and the sign is not given, I'll just draw it. It's an equilibrium. It's an equilibrium. So for this reaction, okay. Yes, for this reaction, if I write the E cell equals to E naught minus 0.059 by N log of product Zn2 positive concentration upon H positive concentration. and raised to power 2. If we add H2SO4, firstly in terms of equilibrium, what will happen? If we add H2SO4, that means we are increasing H positive. If reactants are getting increased, that means equilibrium will shift in the forward direction. That means if reactant is more, the system will synthesize product more. The system will synthesize more product. So that means the reaction will go in forward direction. The reaction will go in the forward direction. That means equilibrium to the right. So either this option or this, either C or D. Now let's see. If we increase H positive concentration, what is happening? If this amount is high, if this amount is more, that means log of this amount will be small. If log of this amount is small and this amount is small, and this is a negative amount, right? This is a negative amount. I don't know if you know, but if you go smaller in log values, they turns negative. If you go smaller in log values, log 1 is 0, right? Beyond that you go, right? That is negative. This value is negative. If this value is negative, negative will be positive, right? So that means the E cell will increase. If you increase H positive concentration, this thing will go negative, and negative, positive. That means your overall cell potential will increase. So it will increase the E and shift the equilibrium to right. Right. Clear? Okay, so how many of you answered C? Let me check. 63%. Good percentage. Okay, one more thing, machas and machis. Please don't distract others. Whatever conversation that you're having here, don't do it here. It's a revision class. We are here for studying only, okay? We are not here for your Instagram exchange or your social media handles exchange. So please don't do that. Go there and talk there if you're not interested in studying, okay? I genuinely request you, like this I request you, okay? Oh my god, there's some error. Maybe you can just refresh and rejoin or something, okay? Okay, concentrate on class. Obviously, if you do that, I would have no other option to block you or something, okay? Don't do that. Don't make me do that, please. Next question. Just remember a little thing. Yes, just remember a tiny little thing here. Yes, so remember, whenever a metal is more reactive, or whenever an element or atom is more reactive, what do you mean by more reactive? More reactive means it is more willing to lose electrons. Okay. Now, if it is more willing to lose electrons, is it getting oxidized or reduced? It is getting oxidized. Okay. Oxidized means it is acting as an anode. Okay. One more conclusion I can draw. If it is getting oxidized, it is acting as an anode. Is it a good reducing agent? Yes, it will be a good reducing agent. Isn't this a quick revision for you all? Am I not solving the question with conceptual knowledge? Okay, we will do one. Okay, please don't spam. I'll just listen here. More reactive means more willing to lose electrons, which means it will get oxidized. Oxidized means it will be the anode. Okay, oxidized means it will be a good reducing agent, right? Because reducing agents are those agents which reduce others and gets oxidized themselves. Now listen here. Cu positive and Al3 positive. Aluminum displaces hydrogen, but copper does not. That means aluminum is more reactive than copper. If aluminum is more reactive than copper, same process, more willing to lose electrons. If it is more willing to lose electrons, one second. If it is more willing to lose electrons, all of your doubts I'll answer after 50th question, okay? Some of your doubts I'll answer after 50th, and then I would really be happy if you wait till the end. I'll answer all of your doubts, okay? I will take the 5-10 extra minutes and I'll answer all of your doubts. Let's not break the flow of the class for now, okay? Okay, answer this one. Aluminum is more reactive, so that means it is more willing to lose electrons. That means it will get oxidized. That means it is an anode. It is the anode. Okay, so copper will be the cathode. We are asked if the potential of this aluminum electrode's potential is being asked. What is the electrode potential of a cell? E cell is equals to E naught cathode minus E naught anode. What is the electrode potential of cathode? That is 0.34. Okay, what is the electrode potential of anode? We need to find that. E naught anode. What is the electrode potential of cell? For cell it is 2 volt. Okay, so electrode potential of anode will be equal to what? 2 minus 0.34, that is 1 minus 1.66. No, plus 1.66. B. Yes, Joe, I saw your answer, correct. Okay. Yes, B. Good. The poll was not there, but it's okay. Yes, okay. What is going on? Okay, B. Done? Okay, next question shall we? Yes. Let's move on to the next question. Same amount of electric current is passed through solutions of AgNO3 and HCl. Okay, if 1.08 gram of silver is obtained in the first case, the amount of hydrogen that is liberated at STP in the second case. Now listen. One is given in gram, but most values are given in centimeter cube. Okay, so that means the answer shall come in volume. Okay, that answer shall come in terms of volume. I'm not ignoring anyone, I'm just focusing on the class, on the bigger picture. We are solving questions, we are doing revision, complete chemistry revision. Okay, so I want you all to have a conceptual knowledge, right? Okay, now listen. This is what we use here. We use Faraday's second law. What is that? According to Faraday's second law, the amount of silver deposited will be directly proportional to the equivalent weight of silver. Okay, it will be directly proportional to the equivalent weight of silver. Okay, we are given two compounds here. We are given silver and we are given hydrogen. Hydrogen gas will also deposit. Okay, now listen, silver. So I can take proportions, right? You know that. So weight of silver upon weight of H2 that is deposited will be equal to equivalent weight of silver, which is 108 by 1, and equivalent weight of hydrogen is also 1. Okay, what is the amount deposited? 1.08 gram. 1.08 gram. If you solve it, the answer will be 0.01. The amount of hydrogen deposited is 0.01 gram. The amount of hydrogen deposited will be 0.01. Okay, if option A is correct, not B. No, the correct answer is option B. Option B. Yes, because we take it. One second. Did I mistake? One second. I take it. Oh yeah, the answer is minus. No. Sorry. Yes, the answer is minus because yes, it is this minus this and plus this. Okay. We took it that side, right? Basic 0.34 minus 2. Yeah, the answer will be minus. The answer will be minus 1 point. Okay. Sorry. Thank you for rectifying my mistake. Done. Okay, now again back to the question. This is the amount of H2 that is deposited. Now you need to convert that amount into volume because you see there is no option like that, right? So you will convert that amount into volume. How will you convert that amount into volume? So we know, what do we know? That 2 mole, around 2 mole. Okay, around 2 mole or 2 gram actually. Okay. 2 gram of H2 has around 22,400 centimeter cube. At STP, 2 gram of H2 has the volume around 22,400 centimeter cube. Okay, how much we have? 0.01 gram. So that will be 22,400 by 2 times 0.01. So that will be 112 centimeter cube. 112 centimeter cube. Yep, it's okay. 112 centimeter cube. So how many of you answered C? Let's check. Okay, the proportions are not looking right. Okay, no, it's okay. I'll explain it again. Don't worry. Yes, C, queen, correct. We took 2 gram because we have H2. Okay, that's why we took 2 gram. Okay, now listen. not 2 mole actually, 2 mole, we have 2 moles also, no, but we are using grams here because the amount is in gram. We want the volume occupied by this much gram of hydrogen. Okay, so according to Faraday's second law, we know that the amount deposited will be directly proportional to equivalent weight. So for silver it is 1.08 gram deposited. What is the equivalent of weight of silver? 108. For hydrogen we need to calculate this amount, but the equivalent weight is 1. Okay, so from here we calculated that the amount of hydrogen deposited it is 0.01 gram. Now after that, 2 gram of hydrogen, okay, what is the weight of H2? 2 gram, right? So 2 gram of hydrogen has around 22,400 centimeter cube volume at STP. We have how many gram of H2? 0.01 gram. So simple unitary method we used, that comes out to be 112 centimeter cube. Okay, we used 2 because H2 has a mass of 2 gram. Okay, and we used mass, not moles, because the answer we need is for this gram, not moles. Okay, yes, so for question 38 the correct answer is option, you guys see. Okay, next question. Which one of the following condition will increase the voltage of the cell represented by the equation? Again, isn't it similar to that zinc one we did? Isn't it similar to that zinc and H positive we did? Okay, isn't it similar to that? So tell me, yes. So tell me, same, I'll write the equation, till then you tell me which will increase the voltage. Voltage means the E cell will increase, right? Which will increase the E cell. Now we know E cell is equal to what? E naught cell minus 0.059 by N log of what? Cu2 positive concentration by Ag positive concentration raised to power 2. Whatever be the stoichiometry, that goes in the power. Now tell me, if I increase the mark if you have any doubt, please wait till the end of the class. I'll answer all of your doubts. Okay, in between I am not answering it, I'm just taking the questions for now. Okay, so if you have any doubt, please hold it till the end, please stay till the end, I'll answer it out, don't worry. Okay, answer this question. So I've written the equation, this is the equation. Which parameter should I change, which dimension should I change so that the overall cell potential will increase? So very easy, I increase the concentration of Ag positive. If I increase the concentration of Ag positive or decrease the concentration of Cu2 positive, in both cases the E cell will increase. We just discussed it. In both cases the E cell will increase. So the answer is increase the concentration of Ag ions, Ag positive ions. That is option D. Now let's see how many of you answered option D. 28%, 48% are going with C. C, increase the concentration of Cu2 positive. How much? Listen, if you increase this concentration, this log value will increase. This log value is negative. If this value is negative, if from E naught cell big value is getting subtracted, right? From E naught cell big value is getting subtracted, that means E cell will be less. E cell will be less. We were looking for the condition which will increase the voltage of the cell. So we are looking for high E cell. For high E cell this value should be less. How will it be less? When Ag positive concentration is high, it will be negative, 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 positive. The E cell will increase. Okay. Okay, yes, D is the correct answer. Good. I am actually looking who is answering correctly. Okay. Yes, good. 1 second. Next question. Okay. Okay. Next question. Conductivity of a saturated solution of sparingly soluble salt is this. This is conductivity. Firstly, it should be clear, conductivity is represented by kappa, that is 1.85 times 10 raised to power minus 5 Simon meter inverse. Okay, solubility product we need to find, KSP we need to find. Firstly, you should have an idea what is the solubility product. So if we have a salt, insoluble salt AB, okay, if we have an insoluble salt AB, okay, whenever we talk about solubility product, we talk about insoluble salt, right? Because they are not soluble, right? They are not soluble, not completely soluble, they are partially soluble. Okay, so it dissociates at as A positive and B negative. Okay, it dissociates as A positive and B negative. That means in the solution there will be some undissolved salt and there will be some dissolved salt, dissolved and undissolved portion. It is there. Okay, now solubility product is what? Solubility product, if this solubility of each ions is S, the solubility product is the product of the concentration of the ions. It is the product of the concentration of the reactants, okay, KSP. So A positive, or solubility in this case you can say. What is the A positive? The solubility, or okay, one more thing. When I use solubility and concentration interconversely in this question, that is correct, because in this case solubility is equal to concentration. In this case solubility is equal to concentration. Okay, so this is be S square. We need to find this S. We need to find this S. And how do you calculate this S? Now listen. The molar conductance at infinite dilution is given. The molar conductance at infinite dilution is given. Okay, and we are given the conductivity also. We are given the conductivity of ions, and we are given the molar conductance at infinite dilution. Can you tell the concentration using that? Yes, concentration, or in this case you can say, you can calculate the solubility. The solubility will be equals to conductivity by molar conductance at infinite dilution. Okay, this is the conductivity of ions. How many ions are there? Maximum. This is the maximum value, and this which is the conductivity, real conductivity. Okay, so solubility will be, this is solubility. The solubility will be 1.85 times 10 raised to power minus 5 by 140 times 10 raised to power minus 4. So the solubility will come out to around it will be 1.32 times 10 raised to power minus 3. Yes, 10 raised to power minus 3 mole per meter cube. Mole per meter cube. Now from meter cube we will convert it into liter. From meter cube we will convert it into liter. I am solving it, before me you solve, okay? Please, before me you solve. Okay? How can we answer in minutes? That comes with practice, but for some questions you can just have an idea but by just looking at the question only. Okay? Okay, now this is the value, right? This is the value of S. Okay, I don't want to convert it into liter and all, it's okay. You have to convert it into firstly into liter, meter cube to liter. So that will be around 1.32 times 10 raised to power minus 6 mole per liter. After that, this is S. This is S. We want the solubility product. Listen, we want the solubility product. The solubility product is S square. That means if we square this quantity, if we take a square of this quantity, we will get solubility square. So the square will come out to be what? 1.32, 13, 1.74. Yes, 1.74 something, right? So here you can save some time. 1.3 square of 1.3 is 1.69. So that is around 1.7 only, right? So we have an option. Yes, okay. Correct answer is D. Correct, Joe. Okay, good. Yes, so all of you are answering D. Where is the poll? I lost the poll. Where is the poll? It's not here yet. You need tips and tricks, Ayush. So Ayush, Jasmine ma'am has made a video about this tips and tricks things where you have the tips and tricks to solve MCQs and all, guessing and everything. So you can go check it there. Sometimes it will work, sometimes it will not. Okay, there is no guarantee, but if you solve it, that is 100% guarantee that it will work. Okay. You have to be little fast in your calculation. The calculations will be comparatively easy. Here see, 1.3 I had an idea, 1.7 I did, simple. Okay, 1.85 by 140, I can have a rough estimate of this. It will come out around 1.5 something, right? You need to be very good in maths, you know, majorly in that tips and tricks thing, that you know, how to simplify it and what can be the closest possible ratio, approximation. You should be good in approximation because the answers are different. You can have an idea even if you approximate your even if you approximate your questions. Okay. I don't teach, Tukka. Good. Next question. Yes, next question. The mass of glucose that should be dissolved in 50 gram of water in order to produce the same lowering of vapor pressure is produced by dissolving 1 gram of urea, as is produced by so see, the relative lowering of vapor pressure is same. The relative lowering of vapor pressure is same. Now, how many of you know that relative lowering of vapor pressure is a colligative property? Colligative property do not depend on the nature of the solute. It only depends on the amount of the solute. Colligative properties are independent of the nature of the solute. They only depends on the amount of solute. Okay. Now, amount of solute. What is the amount of solute? 50 gram mass of glucose that should be added in 50 gram of water. you know one thing, that relative lowering of vapor pressure is directly proportional to the mole fraction of that solute. Is directly proportional to the mole fraction of that solute. Okay. So if both compound, glucose and urea, yeah, we have glucose and urea. So in case of glucose and urea, both cases have same relative lowering of vapor pressure. If both cases have same relative lowering of vapor pressure, that means you can equate the mole fraction, right? You can equate the mole fraction. So for glucose, what it will be? It will be mass of glucose X by 180 will be equal to 1 gram of urea, 1 by 60. Now don't ask me, ma'am, this is not the formula of mole fraction. Macha, why? Because 50 gram of water is constant for both of them. That means same number of moles of water are present in both of them. Same number of moles of water are present in both of them, right? So the answer will be 3 grams. Yes, and all of you answering 3. Done. Good. What? Okay. Clear? See, that's how you save your time. Okay, you just read the question, you don't write this part, you exclude it. Smart calculation, that's what you call it, right? Yes. Is it helpful? Yes, Shravan, it will be helpful. If you're solving the question, tell me by the end how many you got correctly, you know. Some of you are answering all the questions correctly. I'm very proud of you all. And if you are having any problem, that's okay. Okay, we are solving it together. Okay, next question. Which of the following aqueous solution has the highest freezing point? Okay, in this question, there's one thing that you should focus on while answering. The highest freezing point. Highest freezing point, that we are not, means that we are not looking for the depression in freezing point. We are not looking for the highest depression freezing point. Highest freezing point means, okay, which is high? -2 or -8. Obviously, -2 is high freezing point. What is this? This is depression, -2 to -8. This is depression happening. And depression in freezing point is directly proportional to what? Depression in freezing point is directly proportional to Van 't Hoff factor, right? Depression in freezing point is directly proportional to Van 't Hoff factor. Higher the value of Van 't Hoff factor, higher will be the depression in freezing point. Okay? Higher will be the depression in freezing point. But here we are asked the highest freezing point. What do you mean by highest freezing point? So highest freezing point means lowest depression in freezing point. Lowest depression. We are looking for lowest depression. And what do you mean by lowest depression? Lowest depression means least I, least Van 't Hoff factor. Van 't Hoff factor. Okay, Van 't Hoff factor is just a factor that actually tells us how many solute, how much amount of solute is actually present. Okay, you assume something, we see that it is NH4Cl, right? But it won't be NH4Cl. We will have two, NH4 positive and Cl negative. We will have NH4 positive and Cl negative. Okay, so which has the least I? That will be your answer. This has 2 plus 3, 5. This is 2 plus 1, 3. This is 3 plus 1, 4. So this is least. It has only 2. The NH4 positive and Cl negative. Okay, the I is equals to 2. I is 2. Clear? Yes, so how many of you are answering D? Let me check. Good, 50% of you are answering D. Good, close. Okay, done. D, clear? Done. Next question. A hypothetical reaction is happening. This is the mechanism. You have to tell the order of the overall reaction by RDS method. RDS is your rate determining step method. So whenever you are solving these kind of questions, okay, whenever you are solving these kind of questions, 1 second, till then you guys answer. I'll just okay, tell me the answer for this question, please. So for hypothetical reaction, we are being asked the overall order of the rate determining step. So which is the slowest step? The slowest step will always be the rate determining step. Supposedly 5 persons are going, running or walking. They are walking to a same place and they all have to be there together. They all have to reach there together. So which will determine the speed? The person who is walking the slowest, right? Because only when he will reach or she will reach, their goal is complete, right? Only then they can enter, okay? Only then they can enter. Not one chapter, Shravan, there will be multiple chapters. Okay. Tell me, so the rate determining step is this one. The rate determining step will be this one, right? For this, can I write the rate as this? Rate will be equals to K, proportionality constant, A times B2. Now let's look here. The reactant is A2. The reactant, the original reactant is A2, but we are using A here, right? So can we find the value of A? Yes, we can find the value of A. How do you find the value of A? Yes, the order will be 3 by 2. Yes, that is correct. How will you find the value of A? For this reaction is in equilibrium. So I'll calculate the equilibrium constant. That will be A square by A2. So A will be equal to what? A will be equal to Kc into A2 and whole raised to power 1 by 2. Whole raised to power 1 by 2. If I substitute this value here, I will get my answer. If I substitute this value here, I will get my answer. Okay? You guys are not studying. That's not nice actually. That's not nice. You guys are not studying. You guys are bad. Please don't spam here. I request you all, please don't spam here. I have no other option than to block you guys. Don't do that. Okay, now let's see. It will be K times Kc raised to power 1 by 2, A2 raised to power 1 by 2 into B2. Okay, now again, constant times constant will be some other constant. Let's say that is K dash, A2 raised to power 1 by 2 and B2 raised to power 1. So what is the order? It is the sum of these stoichiometry. So sum of these powers that these molar concentration are being raised to. Yes. So the correct answer is 1 by 2 plus 1. The order will be 3 by 2. The order will be 3 by 2. Is it clear? Yes. Is it clear to you all? 3 by 2, 3 by 2, 3 by 2. Yes. Good. And please don't spam it. Yes. You cannot, Shreya, that is not a nice advice. You cannot study and chat at the same time. Okay? So please study, focus on your studies. Your exams are coming up. Okay. Next question. Yes, clear, I think. Half-life of a substance A following first order kinetics is 5 days, starting with 100 gram of A, amount left after 15 days. So we are dealing in days here. We are dealing in days here. Very easy, you can answer it, right? I've solved this question multiple times with you guys. Yes, so if first half-life, half-life is 5 days and we are given 15 days. So in 15 days, how many half-lives have happened? 3 half-lives, right? 15 by 5, that means the half-lives are 3. What is the concentration? If we started with 100 gram, what is the concentration left after 15 days? So the concentration left after 15 days will be initial concentration by 2 raised to power n. Initial concentration by 2 raised to power n. N is the number of half-lives. N is the number of half-lives. Okay. So in this case, that will be 100 by 2 raised to power 3, which is 8. So that will come out to be 12.5 to 1. Yeah, 12.5. Yes, 12.5 gram. That is 12.5 gram. So the amount is 12.5 gram. And yes, almost all of you answered 12.5 gram. Good. Good. Clear? Okay, next question. Good? Okay. If this, see, this is the reverse of that second question. The question that we solved, this is the reverse of that question. Okay, now listen. If 6.25% of a substance is left after 240 minutes in a radioactive decay. So, radioactive decay is a first order reaction, right? It is a first order reaction. Then what will be the half-life? You need to tell me the half-life. Okay, now listen here very carefully. Yeah, correct, Norman. I kind of think that too. Yeah, even I am sorry. Why am I teaching you all? Why don't do that? Please don't do that. Okay, now listen. If 6.25% substance is left after how much time? 240 minutes. After 240 minutes. So let's start with the beginning. Initially we had 100%, right? Okay, after first half-life. Half-life means the concentration is the concentration got exactly half, right? So after first half-life, it got 50%. Okay, from 50%, after second half-life, what happened? This got converted into 25%, half of that initial concentration. Okay, after third half-life, it will be what? 12.5, clear? 12.5, and after fourth half-life, it would have been 6.25. After fourth half-life, how much amount is left? 6.25%. So that means in 240 minutes, 4 half-lives have gone. In 240 minutes, 4 half-lives have happened. Okay, so 240 by 4, that means 1 half-life is of 60 minutes. 1 half-life is of 60 minutes. We just reversed whatever concept we used in the previous question here. Okay, so that means how many half-life? Yes, option A, correct. Good. Next question. The rate constants, this is easy. Can I just leave it to you guys? I don't want to explain it. You just make them equal and then you calculate. K1, the temperature at which K1 equal to K2, that will be 10 raised to power 16 times e raised to power minus 2000 by T will be equal to 10 raised to power 15 times e raised to power minus 1000 by T. Okay, if I calculate it, I already know the answer because I have done it so many times. It's okay. Okay, yes, the answer is the temperature will be 1000 by 2.303 Kelvin. The temperature will be 1000 by 2.303 Kelvin. That's basic maths here. Okay, yes. So for question number 46, we haven't got a poll, but I've seen your answers. Correct answer is option C. Yes. Next question. Yes, 46C. Good. Next question. A first order reaction is half completed in 45 minutes. How long does it need to take 99.9% of the reaction to be completed? I'll give you a short trick for this question. There's a long method and there's a short method. So we'll do the short method. If any one of you want a long method, I can give you that also. But just remember, 99% of any reaction, if 99% of any reaction is completed, then time that is taken to complete 99.9% of that reaction is 10 times the time taken to complete half of that reaction. 99.9%, the time taken to complete 99.9% of any reaction is 10 times the time taken to complete half of that reaction. Okay, simple. Half-life is given to me, 10 times 45, 450 minutes. But again, the answer is in minutes. This is in minutes, but the answer is in hours. So I'll just divide by 60. So that will be 7.5. Okay, 7.5. Okay. Yes, 10 times T half. That is your short trick. Clear? After 50 question break, yes, I will give you break. Don't worry. After 50 questions. Are you tired though? I'm not tired. I'm feeling high. Okay, I'm really high, Josh. Okay, so correct answer is option D. 89%. Good. Okay. Some of you decreased or something. Okay. Yeah, I like to do short. Yeah, short is nice. This one is short method and it will save you some time. Even you are high. Yes, so we can stretch it a little bit, right? We'll have a break obviously, but after maybe 50-60 questions. Let's see. Oh, this is a lengthy question, but it's very easy actually. It's very easy actually. Can you guys solve it? It's very easy. Weight by weight percentage is given. Molecular mass is also given. Freezing point we are talking about here. You need to tell the freezing point of water sample is. You need to tell the freezing point of water sample. So we know depression and freezing point. What is that equal to? The freezing point of pure water minus the freezing point of solution, right? Because there is a depression happening, and that is equals to Ki Kf m. I is Van 't Hoff factor. What is happening here? Association or dissociation? dissociation, right? Ionization means dissociation is happening. Can I give you the formula and can you guys solve it? I'll give you the formula and the approach to solve these kind of questions. I think you can solve it, okay? So, yes, I'll give you the formula first. Okay, so for dissociation, the formula is I equals to 1 plus alpha into n minus 1. Alpha is the degree of dissociation or degree of ionization. What is degree of ionization here? For AB, and for AB it's around how much? 80%, and for XY2 it is 60%. That is degree of dissociation. N is the number of atoms. After dissociation, how many number of atoms are there? N is the number of atoms, okay? So I'll calculate for AB first. For AB, the value of Van 't Hoff factor is 1 plus, what is the degree of dissociation? 80%, 0.8 of N. If AB dissociates, it dissociates as A positive and B negative. That means you have 2. The N is 2 minus 1. Okay, so again you solve it. 1.8 for XY2. Again same thing. 1 plus alpha. What is the degree of dissociation for XY2? 60%. That means 0.6 of how much? N. Number of molecules is 3. 2y and X. 1x and 2y. 3 minus 1, that is 2.2. Okay, now how do you calculate this? So again it is a colligative property. That means both of the depressions will get added on. Both of the depression will get added on. So it will be I1 Kf M1 plus I2 Kf M2. Clear? M1 means from AB. This is from AB and this is from XY2. Okay, if you put the values and solve this question, if you put the values and solve this question, okay, then what will be the answer? Tell me the answer, please. Okay, just tell me the answer. Okay, you calculated the Van 't Hoff factor, simple. Using that Van 't Hoff factor value substituted here. Again, molarity, number of moles of solute present in 1 kilogram of solvent. 1 kilogram of solvent. So you just assume we have, yes, so you just assume we multiply it with 1000. It's very easy. C, yes. So the correct answer is option C. The answer will be 264. 264. Okay. How did I calculate it actually? So it will be 273 minus this value which I need to find, which will be equal to something 8.7. So TFS will be 273 minus 8.7. 273 minus 8.7. That's a basic calculation. This is the path that you follow. This formula was important, rest you know. Okay, you guessed C, Joe. Yeah, that's actually nice for these kind of questions. You have so much calculation, you can guess it. Yes. Okay, for chemistry only C. Wow. If there was an option, okay, it's okay. Next question. Which one of the following complex is an outer orbital complex? Outer orbital complex. So outer orbital complex are formed by what? Weak filled or strong filled? Weak filled ligand. Weak filled ligand forms a outer orbital complex. Strong filled ligand forms inner orbital complex. Strong filled ligand forms inner orbital complex. So tell me which of the following will form outer orbital complex? These will not. Why? These will not. Why? Because CN is a strong filled ligand. Strong filled ligand forms inner orbital, not outer orbital. So it could be either this and this. Now check. CO plus 3, cobalt, iron, cobalt. So 3D7 4s2 plus 3 means 3D6. Okay. This is 3D8. Okay. Now tell me 3D6 and 3D8 which will form inner and which will form outer. So in case of 3D8, if I can visualize it correctly, 1, 2, 3. In case of 3D8, okay, 1, 2, 3, 4, 5, 6, 7, 8. Even if I do pairing, as in strong filled ligand, only one orbital will be empty. Only this orbital will be empty. There is no chance we can make D2sp3. Inner orbital means D2sp3 hybridization, right? And outer orbital means sp3d2. Are there any 2d orbitals empty here? No, there are no 2d orbitals empty. Even if we do pair them, even if we do pair the electrons, the orbital that is empty is only one, which is only 1d. In case of 1d, we can't form this hybridization d2sp3, right? So the answer is option D. In that case, only outer orbital complex is possible. In that case, only outer orbital complex is possible. Okay? One second. Okay. Is it clear? Is it clear to you all? Okay, what is the answer for this? Option D. And how many of you answered? It's 80%. Good. Good. Yes. All friends answered will be D, 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 D. Good. Correct, Joe. Next question. Yes, next question. Nickel combines with a uni-negative monodentate ligand. So much information. Uni-negative, monodentate. That means X minus, right? Yeah. So you need to tell the unpaired electron in nickel and geometry of this complex. Unpaired electron. Okay. Let's see. Nickel is 3d8, 4s2. What is the oxidation state here? Nickel's oxidation state is +2, -4. X minus 4 equals to -2. X will be equal to +2, right? So that means the hybridization is +2. +2 means the electronic configuration is 3d8. 3d8. Now, how many unpaired electrons are there? How many unpaired electrons are there? Tell me. How many unpaired electrons are there? Yeah, I can just, let me. I am trying, okay? I think blocking is the much better option here. I was being nice. Please don't do that. Please don't spam. Okay, let me see. Let me see. 3d8, yes, 3d8. So will it form tetrahedral or will it form square planar? Will it form tetrahedral? Yes, all of you are cleared. So their number of unpaired electrons will be 2 and tetrahedral. Tetrahedral means if we fill the electrons 1, 2, 3, 4, 5, 6, 7, 8. 2 unpaired electrons are there. 2 unpaired electrons are there, and the geometry will be tetrahedral. And the geometry will be tetrahedral. Okay, clear? Yes. Yeah. So the correct answer is. The correct answer is option A, and 62% of you answered option A. One second. Another one, he made a new one. Did he make a new profile? No, he's not there, he's gone. I think it takes some time. It's okay. Ma'am, break. Okay, okay, now I think we need some break. Huh? Do you need some break? Answer this question, then we'll have a break. Okay, answer this question, then we'll have a break. Even I am tired. Okay. Yeah, yes. Please answer this question. 49 answer A. No, 3d8. Outer orbital complex. It will only be formed by nickel because it is 3d8. Even if there is a strong filled ligand and it does the pairing, in that case only one orbital is empty, 1d. But we are having octahedral complex, right? So we need either d2sp3 hybridization or sp3d2. So since 2d orbitals are not there, inner orbital complex will not form. Only outer orbital will form. The next orbitals will involve in hybridization. Okay? Answer this question, then we'll have a break. Okay, the square planar complex. It's a square planar complex, okay. Will it show geometrical or optical? So first thing, square planar complexes have a plane of symmetry. Square planar complexes have a plane of symmetry, okay. If they have a plane of symmetry, that means they do not form optical isomers. Not optical isomers at all. They are not optical isomers. Okay. Now, since all of them are different, all the ligands are different. So, in that case, what they will form? No, Ayush, there will be break. I am tired. Okay, guys, we'll have a little break. Okay. I think yes. Go have your lunches, then we'll finish the 50 questions. Okay? Yes, so 3 geometrical isomers. Yes, 3 geometrical isomers. Now I can help you little bit visualization also. Listen, see. Okay, so if I fix one, let me fix one. A I fixed here, then B, C, D. A again I fixed here. This is 1, right? If A, this is 1, then you have C, B, D. Okay, and then I have A, fix again. C comes, right? B, C, then it will be D, and it will be B, and it will be C. Okay, so if I fix just one, there will be 3 geometrical isomers possible. Okay, 3 geometrical isomers, all have different arrangements. These are the 3 geometrical isomers. Soon, Orion, we're working on it. Okay, something will come in next few days. Okay. Okay, yes. Let's have a break. I'm tired. I want a break, please. Okay. Why is not? It's not moving. Okay. We'll go. We'll add a slide. Okay. Here I'll add. How much long you want actually? I'll just check with you guys. First, what was the answer for this one? 2. Oh, sorry. 3 geometrical isomers. Yes, D. Yes. Correct. D is the correct answer. Okay, now tell me, okay, how much? Oh, that's actually really nice, 180. Oh, you guys are really liking it. I'm happy if you're studying actually. I'm happy in that. My phone got hanged, I think. Okay, so how much? 5 minutes, 10 minutes? 10 minutes, 5 minutes, 30 minutes, 2 minutes, 8 seconds. 1 second. 3 hours. Wow, I'll give you break for like as long as you want. You go, you don't need to take the class. 3 hours break you want, Okay, done. So I'll give you, not yours, not mine, I'll give you 15 minutes break. Okay, after 15 minutes I'll come. Go have your lunch and all. Don't complain later, okay, that I don't have my lunch, because I am going. Okay, then we'll continue our class. 15-minute lunch break. Okay, lunch, snack, whatever you are having, okay, just have it, and then we'll start. Okay, I need, yes, Joe, I saw the likes. Thank you. Okay, thank you everyone. See you in 15 minutes exactly. Be there around 12:45. Okay, we'll start from 12:45. Okay, come back fast. Okay, I'll come back fast, don't worry. No, 15 minutes. We'll be back in 15. Okay. Hello, hello. Good afternoon everyone. So, 1 second. Ma'am, please come back. I came back. Okay. So, are you guys ready? Okay, you guys are talking so much. I was watching your watching your chats. Subject edu all chapters edu sub. Okay. How's the Josh now? Are you done with your lunch? Right? Oh my god, yes, done. Okay, done. So, can we start? If you are ready, we can start. Give a thumbs up, please. 50 questions. Kisan, we have 50 questions left, okay? Then we'll be done, okay? Yes, I was secretly watching you all. You guys, I actually don't understand Kannada, but yeah, I know you guys were talking about some relationship stuff and all, which is very, very bad actually. On a channel where you're studying for your KCET exam, such an important exam, you have an upcoming exam, right? And you are talking about all that stuff, that's actually very bad. You're not nice actually, okay? Anyways, so I'll just give a thumbs up, then we'll start. Okay. Yes, hi. Ma'am, explain. Oh my god, you want me to go to back one? Okay, at the end I will go. Whatever doubt you have, write it down somewhere, and when we are at the last question, then tell me, I'll explain, okay? Karnataka, I'm in Karnataka, I'm from Karnataka state, okay? Explain 51. Okay, 51 was the last one. So, Amaya, right? Amaya, please write it down. I'll answer your question once this live, once we are at the 100th question, okay? Then tell me which question you want me to answer, I'll answer, okay? Okay. Yes, no useless fellows. Okay. Solid state. My original state is solid state. I don't know what you want me to answer, bro. The original state, you know, humans are solid state. We shall start, I think. Yeah, 100 questions. How many marks to get? Indians are also solid, right? In Indians, we are solid, liquid, gas, right? So, Indians also solid. Fake state. Okay, let's focus, guys. Don't do that. Okay. Question number 52, right? Yes, question number 52. Ma'am, tell improvement exam. So improvement exam hall ticket will be told to you by Jasmine ma'am. She has much more knowledge regarding that. Okay, about your second PUC hall ticket, right? Not second PUC. Second PU exam. Yeah. So she'll tell you. Okay, you can go and check her videos. Okay. Yes, Avani, you were in my last class. I told you. You said you had just doubt in solving questions. Okay. Yes, let's start the class. All your doubts will be answered, okay? And for you asking Shetty, right? You're asking about hall tickets. Jasmine ma'am will give you an idea about that, okay? When the hall tickets will released and how to download and everything. Yes. Okay. Okay, Nagraj, welcome to the channel. All are new. I'm also new. Okay, let's start. Next question. The correct order for the wavelengths of light absorbed. Is it visible to you all? Let me check. Is it visible? If it is not, I'll just write here. Listen. We are given here 3 compounds. COCl, NH3 2 positive. Okay, one more important announcement, guys. The poll will be there till 1, okay? Then after that, from 1:30, we'll again begin the poll. So from 1 to 1:30, be nice and answer in the chats only, okay? Answer the question in the chats only, okay? Understood? Yes. So for now, till 1 we have. So till 1, whatever question we are solving, we'll be solving using poll. And then after that, 1:30, we'll again get the poll, okay? Yes. Hi Alekya, so many smileys. Okay, the second compound is, what is happening? Okay, the second compound is CONH3 6 3 positive, and the third compound is COCN 6, 3 negative. Okay. What is happening? Something is happening. I don't know. Let's wait for 1 second. You guys answer this question till then, okay? B, there, I know there's a problem with the wire, I think. Yeah, I think it's not anymore. Okay. So tell me, we have okay, what is going on, guys? Okay, we have 3 type of ligands here, okay? NH3, Cl and Cn. We have 3 type of ligands here, NH3, Cl and Cn. Okay. In these three ligands, which is the strongest fill ligand, if you arrange them in increasing order of crystal filled splitting energy, which is the strong filled ligand, Cn, right? And then after that, NH3, and lowest will be Cl. Okay, this is the increasing order of crystal filled splitting energy, crystal filled splitting energy or crystal filled stabilization energy. Okay, this is the increasing order. Now I know there is a relation between energy and wavelength. What is that relation? So relation between, please Shetty, please don't spam it, huh? Okay, please don't spam it. Your doubt will be answered by Jasmine ma'am. I don't know where is the link and everything. She will answer it out. Please be patient, okay? So if energy is increasing, what is the relation of energy and wavelength? We are talking about wavelength, right? So if energy is increasing, that means the wavelength will be decreasing, right? In this sequence, energy is increasing. The crystal filled splitting energy is increasing. So that means the wavelength will be decreasing. So which will have the shortest wavelength? Cn. This compound will have the shortest wavelength. Which will have the longest wavelength? This one will have the longest wavelength. Okay. So what should be the order? Decreasing order we are looking for. So again, this will have the longest wavelength and Cn, because it is a strong filled ligand. The energy is really high, right? If energy is high, that means wavelength is less. Energy and wavelength are inversely related. Clear? Yes. My voice is delayed. Is it? Oh my god. Oh, is my voice delayed? Okay, just give me 1 second. 1 second. Hello. Just tell me if my voice is still lagging or bit, okay? I am Hello. Is my voice still lagging? Okay, just tell me if my voice is still lagging. Whatever I'm telling, is it lagging? Is it lagging? Better. It's better. Yeah, I'm audible. That's not the issue here. The issue is if my voice is lagging or not. No? It's correct. It's delayed. For some people, it is delayed. No, it's not. No, it is delayed, I think. Okay, I'll fix this. Just give me 2 minutes, huh? Hello everyone. So please let me know if there is the delay audio issue. If there is the audio delay issue again. Yeah, tell me please. No, I think it's okay. Yeah, okay. Perfect. It's like this. It goes black like this. I don't know why. Okay, so for this question, Machi, it's perfect. Okay. Still it's delayed. It's not delayed yet. No, it's not delayed. There's some issue with your phone. It's not delayed now. But the screen keeps on going blank. I don't know why. So hello again, please let me know if you have any issue in voice, and screen is fixed I think, but if you have any issue in voice, please let me know. If it's getting delayed, board is not visible, it's okay, it will be visible. Okay. Board is not visible, it's okay, it will yeah, it's delayed. The voice is delayed. Okay. Voice is delayed. Yes, it's still.
Is it something that we have to do here?
So, yes, Jasmine ma'am is here. Yes. Machi, the board is going black again. The voice is getting delayed, right? Yes. Ma'am, no, it's good. Continue. No, the voice should match my, whatever I'm telling you should match. Is it?
We're talking about that. They're talking about the delay. That's not a problem. You talk, no problem. They'll hear. That's not.
Now it's perfect. Now it's syncing. Yes, it's matching. Okay, done. Okay, done. Thank you. Okay, let's start. We have already wasted so much of our time. Okay, done. So for this question again, as the energy is increasing, as the energy is increasing, what is happening here? If the energy is increasing, just stay for 5 minutes. That's all. If the energy is increasing, what is happening? If energy increases, then the wavelength decreases. Okay. If the wavelength decreases, what does that mean? Okay, the light absorbed will be of lesser wavelength, right? Yes, it's perfect. Correct. Okay. So what should be the answer for this one? What should be the answer for this one? The correct answer is option A. Correct answer is option A, because as I told you, the least crystal field splitting energy is for Cl. So that means the longest wavelength will be for Cl only. The longest wavelength will be for Cl only. Yes, Cauchy, Joe, distortion, right? Yes, correct. Good. Voice is lagging. Nidhi, is anyone else having any issue with voice? Please let me know again. Okay, I thought it was good now. Okay, next question. Answer the question. Which of the following complexes, statement about this complex is wrong? It's not clear. What is not clear? It's not syncing. Let's go mine, it's perfect. Voice lagging is fine. Okay, continue. Okay, which statement is incorrect regarding this complex? You have this complex Cr NH3 6 Cl3. Okay, so the complex is paramagnetic, outer orbital gives white precipitate with silver nitrate. The complex involves D2sp3 hybridization and is octahedral in shape. So firstly, is this complex paramagnetic? Is this complex paramagnetic? Let's see the electronic configuration first of all. What is the charge here? +3. Chromium in +3. What is the electronic configuration? What is the electronic configuration for chromium? 3d 5 4s 1. 3d 5 4s 1. Clear? So if we remove 3 electrons, it will be 3d3. It will be 3d3. Is it paramagnetic or is it diamagnetic? Is it paramagnetic or is it diamagnetic? Little loud. I am shouting. You want loud? Okay. Little loud. Voice is fine, I think, but yeah, they're still saying someone have issue. Yes, it is paramagnetic because only 3 electrons are there, and it is octahedral, obviously, right? So firstly, we will fill T2G 1, 2, 3, and then we will fill Eg, right? There is no electron in Eg. Okay. Yes, it is paramagnetic. Not diamagnetic. Why are you saying diamagnetic? Why are you saying diamagnetic? So yes, it is paramagnetic. The complex is paramagnetic. That is a correct statement. The complex is an outer orbital complex. Outer orbital. Is it outer orbital or is it inner orbital? Is it outer orbital or is it inner orbital? Yes, answer is B. Is it outer orbital or is it inner orbital? Yes, answer is B. Is it still lagging? Joe, you are saying it's lagging. Is it still lagging? I will explain, don't worry. Okay, so let's try again. No, it's not. Okay, listen, we are given this complex chromium NH36 Cl3. We need to find which is the incorrect statement about this particular complex. Okay. Okay, now see. What is the electronic configuration? Cr plus 3. Cr plus 3 means 3d3. 3 electrons are there. So is the complex paramagnetic or diamagnetic? The complex is paramagnetic. The complex is paramagnetic. Okay? No, it's not. Okay. Yes, done. Light up. 3. No. Okay. 3d3 electrons, the complex is paramagnetic. Outer orbital or inner orbital complex. So see, when you are filling the electrons, how many electrons you have here? 3 electrons. 1, 2, 3. 2 orbitals are empty. 2 d orbitals are empty. So which hybridization is possible? D2sp3. D2sp3 hybridization is possible. So is it an inner orbital or outer orbital? Is it an inner orbital complex or outer orbital complex? It is a inner orbital complex. It is an inner orbital complex. Why? Because we don't have to do anything. Already 2d orbitals are empty. If already 2d orbitals are empty, then we can have D2sp3 hybridization, right? It already have D2sp3 hybridization, right? So the incorrect statement will be outer orbital because it is an inner orbital complex. The complex gives white precipitate with silver nitrate solution. White precipitate will be coming from these. Silver nitrate will react with this complex, and since we have 3 Cl negative ions, what will happen? In that case we will get 3 AgCl. The white precipitate is coming from these 3 AgCl. Okay, clear? Yes. So for this question, how many of you are answering B? Let me check. 81%, right? Again, the complex gives white precipitate. Yes, it does. The complex involves D2sp3 hybridization and is octahedral in shape. That is also correct. Is it clear, everyone? Yes. Is it clear, everyone? Okay. Is it clear to everyone? Done? Okay. Next question. Which of the following system is an octahedral complex has maximum unpaired electrons? Maximum unpaired electrons. Okay, this one is very easy, right? Everyone can guess it? Yes. So D7 high spin. Firstly, low spin won't be having unpaired electrons. Why? Because in case of low spin, the electrons are getting paired. In case of low spin, the electron is already getting paired. But if it is a high spin, there's a chance there will be unpaired electrons. So if you want D4 low spin, D4 low spin, we are talking about octahedral complexes, right? We are talking about octahedral complexes. Which question you want me to explain again? What's your name? Hema. Hema, do one thing. Whatever question you want me to explain, please write it down. At the end of the live, and when we done 100 questions, I'll explain your doubt, okay? For now, let's go in the flow, okay? Yes. Yes, Arohi, but you also need to work on other things. Okay, now listen. For octahedral complexes, we have splitting in such way. Below is T2G and this above is EG. Okay, D4 low spin. D4 low spin. Okay, 1, 2, 3, 4. How many unpaired electrons are there? How many unpaired electrons are there? 2 unpaired electrons. Okay. In case of D7 high spin, high spin means pairing is not there. 1, 2, 3, 4, 5, 6, 7. How many unpaired electrons? 3. 1, 2, 3. Number of unpaired electrons is 3. D9, even if it is high spin, even if it is low spin, only one unpaired electron is there. D9, we already know that, right? Okay. D6 low spin, again, low spin means all the electrons are paired. So D6 low spin will have 0 unpaired electrons. D6 low spin will have 0 unpaired electrons. So which will have the highest maximum number of unpaired electrons? Yes, maximum number of unpaired electrons is present in B, D7 high spin. And I see how many of you answered B7? Yes, 77% of you answered B. Correct. Okay. Clear? Okay, let's move on to the next question. Good. Next question. Crystal filled splitting energy for COCl6 4 negative is given. The crystal filled splitting energy for COCl4 is being asked. What is this? This is octahedral. What is this? This is octahedral. This is octahedral. Okay. What is this? COCl4 2 minus. Tetrahedral. Right? This is tetrahedral. Clear? Because obviously Cl is a weak filled ligand. Weak filled ligand makes tetrahedral complexes. Strong filled ligand makes square planar complexes. Okay? Done? Yes. ROE, stay till the end. I'll answer your doubt. Okay? Don't worry. A is the correct answer. A is the correct answer. Okay, okay, okay. A. Now listen. What is the relation between crystal filled splitting energy for octahedral and tetrahedral complexes? What is that relation? That relation is very simple. It is equals to 4 by 9. The tetrahedral, the splitting energy, crystal filled splitting energy for tetrahedral complexes is equals to 4 by 9 times of crystal filled splitting energy for octahedral complexes. Now this energy, yes, correct, Trisha. Okay, so this energy is given to us how much? 18,000 centimeter inverse. This is 18,000 centimeter inverse. So it will be 4 by 9 times 18,000. So that will be what? How much? 8,000, right? 4 times 2 means 8,000, right? Yes, A. So that means the correct answer is A. And I see bachas, all of you answered correctly. Correct, Joe. Amaya, Joe, Show. Okay. No, I am reading it. Don't worry, Trisha. I am reading your comments. Maybe I can't say name because we are solving 100 questions, okay? But obviously, I remember. You got 100 in chemistry, PU2. Good. Very good. Congratulations. Okay. Next question. Yes. I got 100. Good. Next question. When MnO2 is fused with KOH in the presence of air, the product along with its color is. When MnO2 is fused with potassium hydroxide in presence of air. In presence of air. What is the product? What is the product? So when manganese oxide is fused with potassium hydroxide in presence of air. In presence of air. Yes. What will be the answer? Tell me. I'm not writing the product yet. If I write the product, the reaction is over. Yes. Correct answer. A, B. What are you telling me? K2. Yes. MnO4 and the color is green. Yes. The product is K2MnO4 and the color is green. The color is green. Correct answer is option A, not B. Correct answer is option A. Okay. Yes, that is manganate. This is manganate. This is manganate. Yes. How, ma'am? Divya, this is a reaction that happened in laboratory. We are just remembering it, revising it, what is happening there. So when manganese oxide is treated with potassium hydroxide in presence of oxygen, it gets converted into potassium manganate. It gets converted into potassium manganate. Okay, and that potassium manganate is green colored. That potassium manganate is green color. Okay, just remember it. Whenever manganese oxide is there, it gets converted into potassium manganate. Manganate is green in color. Good. Next question. 57. Question number 57. I did not change. Okay. Which pair of compounds is expected to show similar color? Similar color. So firstly, you should have what is the oxidation state of these. What is the oxidation state of these? Yes, Queen, you have to read lab stuff because there are practical questions that 2 to 3 practical questions will be coming. 2 to 3 questions from your PU1 and PU2 practicals, okay? 2 to 3 questions will come, practical questions, okay? Yes. Yeah, you need to learn the reactions. Yes. So answer, tell me the answer. FeCl2, Fe plus 2, right? Okay. CuCl2, Cu plus 2. Okay. Again, Mn plus 2. Here VO, in case of VO it will be plus 3. Plus 3. Okay. Which will have similar color in aqueous medium, which will have similar color. Yes, Pu1 and Pu2 both. Yes. With yes, salt analysis questions will come. Yes, salt analysis questions will also come. Good. So I think 2 and 2 4. Okay, this is plus 4. This is plus 4. This is plus 4, which will have similar color. The similar color will be shown by these two, because Fe plus 4, Fe plus 2 and V plus 4. Vanadium 4 positive and iron 2 positive, both have same color. Both have, 1 second. Oh no. Those Cu, copper. Yes, copper. Vanadium 4 positive and copper 2 positive. Both have blue color. Clear? Fe plus 2, iron normally green color, right? Iron is iron ion, ferric ion. This ion is green color. Okay. Manganese is pink. Manganese color is pink. Mn2 positive is pink color. Okay. Copper, we remember, right? Copper is blue in color, and V4 positive, vanadium 4 positive is also blue in color. Okay. Why are they same color, ma'am? They are same color because they absorb the same, they absorb the light of same wavelength. So the complementary color is same. So they absorb the, if it is VibG or if they are showing blue color, so they are absorbing VBGYOR. Orange. They are observing the light corresponding to orange wavelength, and they are emitting the light that is blue, which is the complementary color of orange. Okay. How to remember color? We just gave you a lunch. So to remember color, make a color wheel. Okay, and do 6 parts. Do 6 parts. This is 6. 1, 2, 3, 4, 5, 6. And then write V, B, G, Y, O, R. Clear? So whatever color is absorbed, let's say if any compound or any complex absorbs violet color, okay, which color will it show? It will show the complementary color. What is the complementary color, ma'am? The complementary color is the color that is directly in front of it in color wheel. So if violet light is absorbed, it will show yellow color. Okay, if blue light is absorbed, it will show orange color, and vice versa. If red light is absorbed, it will show green color. Similarly, if green light is absorbed, it will show red color. Yellow is absorbed, violet color. Orange is absorbed, blue color. That's how you remember it. Okay. That's how you remember it. Opposite of circle. These are complementary color wheel. This is a complementary color wheel. Complementary color wheel. Okay. So the correct answer is option B. Clear? Clear? Any doubt you have, I'll answer it. Please answer the questions. Okay, we have 100 questions to do. Okay, next question. Ammonium dichromate is used in some fireworks. The green colored powder blown in the air. So normally when you do fireworks, I think when you any firecrackers you fire, right, during Diwali and all. So during that time, NJ Tech Guide, please stop spamming. I will answer your doubt. Don't worry. Okay, I'll answer your doubt. Now tell me, ammonium dichromate, when it is used in fireworks, so that green color powder is of what? That green color powder is of what? We are not having polls this time. Wait for 5 more minutes. Distortion, I just told you, the complementary color wheel is there. Okay, and then you just need to remember one more thing I forgot to add there. So when you go from this VibGyor, you have VibGyor, right? So when you are going from this to this, violet to red, what is happening? The wavelength is increasing. If wavelength is increasing, then energy is decreasing. This relation will help you. If you remember this, even if you do not know the exact value, they will give you the wavelength or they will tell you about the energy, and then you can figure out which wavelength light is being absorbed, and then the complementary color will be shown by that complex. Okay. Yes, so you don't need to memorize all of them, but for ions you can do, right? Ions are very easy. Copper is blue, iron is green, manganese is pink, right? Vanadium is also blue. Indigo is not there. Yeah, indigo is not there. Violet and indigo you can consider same only, same range, violet and indigo. Okay. Okay, now for this question again, it gets the brown color, the green color is due to chromic oxide. The green color is due to chromic oxide. This is chromic oxide. Ammonium dichromate, NH4 twice Cr2O7, right? So if you heat it, what are you doing when you're firing any fireworks? What are you doing? You're burning it, right? Okay, so it breaks down into nitrogen plus chromic oxide plus chromic oxide plus water, plus chromic oxide plus water. Okay, clear? Yes, the correct answer is option B. Option B. Okay. Number of moles of K2Cr2O7 reduced by 1 mole of SN2 positive. 1 mole of SN2 positive. So for this, you should remember one thing. So SN2 positive gets converted into SN4 positive. So how many electrons are there? 2 electrons. Okay. Now focus here. Cr2O7 2 negative. Cr2O7 2 negative. What is get converted into? It gets converted into Cr3 positive. Right? Here it is plus 14 to 6. Plus 6 to plus 3 it's going. So that means one chromium needs 3 electrons. How many chromium are there? 2 chromiums are there. So that means we need 6 electrons. We need 6 electrons. Is it clear? SN2 positive is getting converted into SN4 positive. Why? Because K2Cr2O7 is getting reduced by SN2 positive. So SN2 positive will go to SN4 positive. We know the oxidation state. So that means it is losing 2 electrons. Okay. Now for K2Cr2O7, it gets converted into, after reduction, it gets converted into chromium 3 positive. Chromium 3 positive means oxidation state is going from plus 6 to plus 3. That means 3 electrons are, it is adding 3 electrons. It is adding 3 electrons. How many chromium are there? 2 chromium. So 6 electrons are there, right? We know this much. Okay. You need to calculate the number of moles that are reduced by 1 mole of SN2 positive. 1 mole of SN2 positive. 1 by 6. How 1 by 6? Very easy. It's straight in front of you. Straight in front of you. So use this one approach. Okay, whenever you find question like this, these are from DNA block, use this simple approach. Moles of K2Cr2O7 times the number of electrons it needs is equals to moles of SN2 positive times the number of electrons it is giving, right? So you can, because this will be balanced, the number of moles that are getting oxidized, that are getting reduced should be equal to the number of moles that are getting oxidized, right? Oxidized. Basically, in a redox reaction, what is happening? The number of electrons that are getting lost, they are being gained by some other species, right? So obviously nothing is going to waste, right? So here the number of moles that are getting reduced should be equal to the number of moles that are getting oxidized, right? So how many number of moles of K2Cr2O7? We don't know. We need to figure that out. So it is X, let's say. How many number of electrons are involved? For 1 K2Cr2O7, for 1 mole of K2Cr2O7, we need 6 electrons. How many electrons we need? 6 electrons. Okay, it should be equal to how many moles of SN2 positive? 1 mole of SN2 positive. 1 mole of SN2 positive. How many electrons are being provided by SN2 positive? 2 electrons. 1 mole of SN2 positive provides 2 electrons. Okay. 2. So X will be equals to 2 by 6, that is 1 by 3. So that means 1 by 3 moles of K2Cr2O7 will be reduced by 1 mole of SN2 positive. If you want to reduce it completely, how many moles you need? So if let's say I want to reduce it completely, 1 by 6 is 1 by 3 is there, right? So that means thrice the amount. We need 3 mole of SN2 positive. Is it clear? We need 3 moles of SN2 positive. Is it clear, everyone? Yes, 1 by 3. So the correct answer will be 1 by 3. The correct answer will be 1 by 3. 3. Okay, I don't want to complicate it, just this much we know. After this we can do this approach, that the number of moles that are getting reduced should be equal to the number of moles that are getting oxidized. Okay, the balance should be there. Okay, yet it's a B. Okay, next question. Which of the following is an amphoteric oxide? So I'll just give you a little trick, till then you answer me. Okay, I'll give you a little trick. Okay, now listen. You have 3 type of oxidation state. You have low oxidation state, you have medium oxidation state, intermediate, okay, and you have high oxidation state. Firstly, these all are your transition metals. So transition metals show an oxidation state from +2 to +7. +2 to +7. So this is the low oxidation state. In between you have +3, +4, +5. They are your medium oxidation state. +6, +7 are your high oxidation state. Okay, clear? So if you have low oxidation state, if you have ions which are low oxidation state, they forms what kind of oxides? Basic oxides. They form basic oxides. If we have medium oxidation state, they forms amphoteric oxides. And if we have high oxidation state, if the metal ion have high oxidation state, they will form what? Acidic oxides. They will form acidic oxide. Now let's see the oxidation state of each of these. What is the oxidation state of vanadium and what is the oxidation state of chromium? What is the oxidation state of vanadium and what is the oxidation state of chromium? +5. Yes, +5, +3, +5. Okay, for vanadium it is +5, for chromium it is +3. Okay, for manganese, how much is it for manganese? +7. Yes, +7. For this one it is +2. Okay, V2O4 is also there, right? So 4 times 2, 8 by 2 + 4 + 4. Okay, now see, +7, this is acidic. This is acidic oxide, not amphoteric oxide. Okay, here it is +2 and V2O5 is +5. +5. Here it is +3. So obviously this is not the correct answer. Then again there we have +4 and +5. +2 is really low. Low means it is a basic oxide. So it could be either option A and it could be either option D. It could be either option A or it could be either option D. So what is it? Which is the correct answer? Tell me. A. Yes, the correct answer is option A. Yes. 1 second, let me just cross check. Yes, the correct answer is option A. Yes, the correct answer is option A. Because both have medium oxidation state. Medium oxidation state, okay? Clear? Yes, A, Trisha, correct. Next question. In an experiment, this much Faraday of electricity is passed. 1m solution. Google answer. Are you Googling answer? Okay. So this much Faraday of electricity is passed through 400 ml of 1m solution of NaCl. What would be the pH of the solution after electrolysis? What would be the pH? What would be the pH? pH, you need to tell me the pH. So what is happening here? Electrolysis is happening of NaCl. So at cathode, what happens at cathode? Reduction happens at cathode, right? Reduction happens at cathode. So we have two ions here, Na positive and H positive. Na positive and H positive. Either you can get sodium or you can get hydrogen. When aqueous solution is there, aqueous solution of NaCl is there, either you can get sodium or you can get hydrogen. Okay, what will we get here? We get hydrogen. We get hydrogen. Okay, yes, we get hydrogen. We get hydrogen. What is going on here? What is the reaction? This is the reaction that is happening, right? So, something is going on. I don't understand your face. Okay, answer the question. Now the poll is back. Okay, answer it. So listen. This is the reaction that is happening at cathode. So, two electrons, from two electrons, how much OH negative we are getting? We are getting 2 OH negative. Why are we focusing on OH negative, ma'am? Because we want to calculate the pH of the solution. We want to calculate the pH of the solution. Okay, 2 OH negative. For 2 OH negative, how much electrons you need? 2 electrons. 2 electrons means 2 Faraday. For 1 OH negative, 1 OH negative, how much electrons you need? 1 Faraday. 1 mole of electrons means 1 Faraday, right? 2 mole of electrons means 2 Faraday. We need 1 OH negative. How much electrons are required to produce 1 OH negative? 1 Faraday, right? 1 OH negative. How many Faraday we have? 0.004, 0.04 Faraday. So that means it will synthesize how many? So that means it will produce how many mole of OH negative? It will produce how many mole of OH negative? 0.04 mole of OH negative. Mole of OH negative. Something clicked in your brain. Moles is there, volume is there. Can I get the what? Concentration, right? If OH negative concentration is known to me, then I can calculate the pH. Yes, I can calculate the pH then. Very easy, right? So listen. This much mole is there. So concentration will be what? Concentration of OH negative will be number of moles per unit volume. Volume. What is the volume? 400 ml. 0.4. 0.4. So that will come out to be 0.1. 0.1. Okay. Now OH negative concentration is 0.1. If OH negative concentration is 0.1, what will be the pH? What will be the pH? We can calculate pOH. pOH is negative logarithm of OH negative. That will be negative logarithm of 0.1. What will be the pH? 1. pOH will be 1. If pOH is 1, what is pH? What is pH? pH is 14 minus pOH. 14 minus pOH. That means the pH is 13. The pH is 13. Okay, and how many of you answered? See, you guys are really confused. Please don't do it. Please don't do it. Ma'am, I got 13. Yes, you got 13. Good, queen. It's okay, it's okay. Joe, you also answered incorrectly, I think. I wrote the formula wrong. It's okay, it's okay. Listen. Okay, so when you're dealing with these kind of questions, this is electrochemistry with a twist of ionic equilibrium. Yes, electrochemistry with a twist of ionic equilibrium. So we have aqueous NaCl. What is happening at cathode? At cathode we are getting OH negative, right? At cathode we are getting OH negative. This will determine the concentration, right? OH negative or H positive, they will determine the pH. They will determine the pH of any solution. Okay. Now at cathode, what is happening? This is the reaction. 2 electrons, right? So again, I can just simplify it also. Did I? Okay. One second. Now this is balanced. Now listen, this is a reaction that is happening. 2 electrons are needed to produce 2 electrons produce 2 mole of OH negative. 2 electron means 2 Faraday. So 1 Faraday will produce 1 mole of OH negative. How many Faraday we have? 0.04 Faraday. 0.04 Faraday will produce 0.04 mole of OH negative. Now we have the moles, we have the volume. Can we calculate the concentration of OH negative? Yes, we can. We calculated the concentration of OH negative. Now this concentration need to be put in this equation, POH. POH is equals to negative logarithm of OH negative. Negative logarithm of 0.1 means the POH is 1. If POH is 1, then pH will be 14 minus POH. That is 14 minus 1, that is 13. Okay. Again reaction came because this is the reaction, anode and cathode. This reaction happens. We have Na positive and H positive. H positive at cathode reduction happens. That means addition of electrons. Addition of electrons. How many electrons are there? 2 electrons are needed to convert H positive to H2. In between these two, H positive have lower reduction potential. H positive have lower, H positive has higher reduction potential. That's why it get reduced. Okay. Okay. Next question. Hey, I did not mark the question. I did answer. Okay. The mass of ethanol that should be added to 2 liter of water so that the solution freezes at minus 2 degrees Celsius. It's very easy. It's not confusing. You're just confusing it in your brain. OH negative concentration we determined. Using 0.04 Faraday, how much OH negative? 0.04 moles. We calculated the concentration using the number of moles. Number of moles per unit volume gives us the concentration. The concentration came out to be 0.1. We calculated POH because we can't calculate pH from OH negative, but we can calculate POH from OH negative, right? So pH is equals to negative logarithm of OH negative, negative logarithm of 0.1, that means 1, right? The POH is 1. pH will be equals to 14 minus POH. 14 minus 1 means 13. Answer this question. The mass of ethanol that should be added to 2 liter water so that the solution freezes at minus 2 degrees Celsius. So that the solution freezes at minus 2 degree Celsius. Okay. I don't want to make this reaction too big. Freezes at 2 degrees Celsius, minus 2. That means this is the solutions. This is the solutions melting, solutions freezing point. Okay. What is the freezing point of water? 0. 0 minus minus 2. It should be equal to KFM. KF is 1.86. M, molarity is what? Mass. We don't know the mass. Let's put it X. By ethanol's molecular mass is 46 times 2 liter of water. 2 liter of water. Density is 1. Water density is 1. So 2 liter is equals to 2 kilogram, right? 2 liter equals to 2 kilogram. Okay. All the values are known to us. X will be equal to, just calculate 2 times 46 by 1.86. So if I am correct, it will be around 62. It should be around 98.9. Yes, it should be around 98.9, and you guys calculated it. 35 of you have. Just calculate it once. Just then let me know. Yes, the correct answer is C. And let me see. B or C are equal. Just calculate it once, guys. See, del TF, I did not want to make it too long. KF, M. M is the molarity, right? Molarity is the, M is the molality. Number of moles of solute dissolved in present in 1 kilogram of solvent. How much solvent is there? 2 liter. Water density is 1, right? So that means 2 liter means 2 kilogram. 2 kilogram is there, okay? Now this is what? Molality, this is KF, this is del TF. The freezing point is now minus 2. What is the original freezing point? 0 degrees Celsius. 0 minus minus 2. Simple. Okay, yes. So the correct answer is option C. Next question. 200 ml of an aqueous solution protein. Osmotic pressure is given. You need to calculate the molar mass. I already know the relation. Pi equals to CRT. Okay. Okay. Pi is given. Pi is 2.57 times 10 raised to power minus 3 equals to concentration. What values are given to us? ml of aqueous solution of a protein contains this much amount of solute. So again, concentration in terms of molality is given. Concentration in terms of molarity is given. Molarity, okay? Okay, so that will be 1.26 by molecular weight of protein times 200 ml. 200 ml. Again, convert it into liter, 1000. RT, R is value is already given, 0.083 times 0.083 times temperature is also given, 300. This is just your calculation. The M, you take it on the left hand side, all the values you take on the right hand side. Calculate it and tell me. Calculate it and tell me, okay? I'm not telling you the answer right away. Yes, once it's above 50, we move on to the next question. You tell me the answer actually. D, yes. Okay. Vijay, D, okay. Done? Yes. Almost there. Almost there. 50%. Yes. So the correct answer is D. If you calculate it, it will come out to be 61,000 something. Okay? Yes. This is the calculation you had to do. I'll write it nicely here. It will be 1.26 times 1.26 times 1000 by 2.57 times 10 raised to power minus 3 times 300 times 0.083. The answer will be 61,038 gram per mole. Is it clear? Okay, yes, it's clear to you all. Next question, shall we? Yes. Equimolar aqueous solution of NaCl and BaCl2 are prepared. Equimolar means the concentration is same. Okay. The freezing point of NaCl is -2, freezing point of BaCl2 is Now listen. Yes, some of you are actually at this point it's getting irritated. Don't do that. Please don't do that. I would have you got I would block you guys. Okay, don't do that. Please don't do that. I remember your name who are doing that. Oh my god. I don't want to do that. That is not nice. Approximation, that depends how much difference you have in your answer. If your answers are really closely spaced, then obviously take the lower value. Normally in approximation you take the lower value. If it's 31.5 or 6, then you take 32. If it's below 31.5, then you take 30 only. Okay? Sorry, 31 only. Yes, Divya, you are disturbing the whole class. Yes, don't do that. Yeah, I'm trying. Which people are there? I don't. Tell me the answer. Where's the poll? Tell me the answer for this one. So if equimolar aqueous solutions are there and you are told the freezing point of NaCl is -2, so what should be the freezing point of BaCl2? I know that depression in freezing point is kind of directly proportional to I. Vandorf factor, right? We are given two solutions which are equimolar. That means molarity is same. That means the molarity is same. Please, if I found one more message this time, I promise I'll block you. Don't do that. Please don't do that. Okay, so for 2 I am calculating, for BaCl2 I am calculating, for NaCl it's given. Okay, del Tf, that means del Tf for BaCl2 by del Tf for NaCl should be equal to I BaCl2, the Vandorf factor for BaCl2 and the Vandorf factor for NaCl. What is the Vandorf factor for BaCl2? 2Cl1Ba, 3. What is the Vandorf factor for NaCl? 2. What is the value of this? Del Tf, that is -2, right? If I calculate it, the answer will be -3 degrees Celsius. How many of you answered 9? 9 B. B. Yes, the correct answer is B. Correct, Trisha. Okay, next question. The freezing point depression constant for water is this. That means Kf value is given. If 5 gram of Na2SO4 is added, this much gram, the freezing point is changed by minus 3.8782, or calculate the Van 't Hoff factor. This is a direct relation. This is a direct relation like this. You solve it. Del Tf will be equals to I Kf m. This value is given, this value is given, this value is also given. Okay, the freezing point is changed by minus 3.82 degrees Celsius. Change is given. So that will be minus 3.82 equals to I, we don't know, times Kf is 1.86, and molarity, the data for molarity is given to us. The data for molarity is given to us. 5 gram of Na2SO4, the molecular weight of Na2SO4, okay, is dissolved in 45 gram of water. 45 gram of water, okay, 45 gram of water. Its molecular weight is around how much? Question number 65. Wrote it somewhere. 142. This is 142. Okay, only this value is unknown. Only this value is unknown. Changed by minus 3. Clear? Changed by minus 3.82. So, what should be the answer? Tell me the answer actually. I am not writing the answer right away. Tell me the answer. Please, please, please. Yes. Vote, 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 vote. Are they still going? I don't see any messages now. I want them actually. I think they listened. C. It's not C actually. Is it? No, it's not C. The answer will be 2.63. 2.63. That's D. That's D, not C. So how many of you answered D? Now you're only 18%. How are you doing your calculation this time? Simple. I is this side, you take everything on the left hand side. Calculation heavy. You can take approximation if they are little calculation heavy. So it will be around, for what I got, like 4 by 2 something. But since the values are closely spaced, you need the exact number. You need the exact number. I'll tell you 3.82, 1.86. times that will be around 0.78 something. Okay, so your answer will be 3.82 by 1.45. That is 2.63. Okay. Yeah, it's okay, Avani. It happens sometimes. The calculation is little tougher on this one. You take approximations. How do you take approximation? Let's see. You take it 4, maybe you can take it 4, you take it this 2, okay, then again this one part you calculate alag se separately, and this one you can calculate separately, okay, and then you just merge. So take approximation as much as you can, you will get a closer answer. Okay, questions are easy. I know the questions are easy, only the calculation is there. Yeah, we take approx, then that's why I'm saying, in this case you need the exact values. That's the problem. That approximation will only work if you have distinct answers. So if you, and there is difference between your answers, okay, but if the answer are closely spaced, like this 0, 2.05, 2.6, that is close, right? So in that case you need the exact value. Okay, yes, I'm looking full. I'm tired actually. This question, okay, reduction potential of aluminum, sorry. Reduction potential of aluminum. I'll tell you the data. Obviously, which will be anode, which will be cathode, you know that. Aluminum is more reactive, that will be your anode, and silver will be cathode. Okay, so cell potential E naught cell is equals to what? E naught anode minus E naught cathode. Sorry, E naught cathode minus E naught anode. E naught anode. So for cathode the value is what? 0.80 minus E naught anode we need to calculate. The cell potential is 2.46. You calculate and it will come out to be minus or plus? Minus 1.66 volt. Yes, so that one was easy. Some of you were answering incorrect, oh. Yes, silver undergoing reduction, so silver is the cathode and aluminum will be the anode. I'm doing good actually. If you guys study, I feel the josh. Okay, I am also energized. But if you guys just fighting among each other or doing unnecessary texting, then obviously my josh also goes down. Okay. You didn't get what? Aluminum is displacing hydrogen, but silver is not. That means aluminum is more reactive. If something is more reactive, that means it is losing electrons. Losing electrons means oxidation. Oxidation means anode. This is your anode, then that means this will be your cathode. And cell potential is cathode minus anode. E naught cathode minus E naught anode. Okay, now anode, the cathode value we know. For silver it is given. For cell potential we also know. We need to calculate the E naught anode only, that is the aluminum potential. Okay, so Arvind, I'm thinking since it's 2 I think, so it will end by 3, max 3 I think. Okay, 40 questions are there, we can finish it. Yes, before 4 we'll finish. Okay, that is if you guys are consistent, if you guys are answering, I can finish it in 15 minutes. I solved all these questions already. Okay, yes, so that depends on you, bacha. Your josh should be really high. We are towards the end of the class, almost 70 questions. Yes, how's the josh? How's the josh, guys? Next question. Oh, she's asking next question. Okay, done. Next question. Okay. If the josh is high, please give a thumbs up. Okay, give me this thumbs up so that I have an idea you are listening to the class, you are having high. Okay, good, full josh. Okay, you had lunch, right? Because I also had lunch. Lunch makes you sleepy, but don't sleep, we are solving questions. Yes, it's really high. Okay, good. Next question, shall we? Okay, next question. The hydrogen electrode is dipped in a solution at pH 3. The potential would be, you calculate. Okay, you guys calculate. Okay, I'll give you the reaction, you guys calculate. Okay, yes or no? The poll will come, you answer. Okay, yes, the poll will come, you solve it and answer. pH is 3. Okay, this is the reaction that is happening. I'll give you the formula also. How do you solve this question? This is the reaction that is happening. Okay, this is the reduction potential, right? So E naught reduction, we are asked to calculate the reduction. So E reduction will be E naught reduction minus 0.059 by, how many electrons are there? 1 log of H2. Pressure of H2 is 1 atm. Okay, 1 by H positive. Okay, pH is given to us. pH means negative logarithm of H positive is 3. Negative logarithm of H positive is 3. Reduction potential, standard reduction potential for hydrogen electrode is 0. It is 0, right? So that is 0 minus 0.059 times 3. Just this much calculation, macha. Just this much calculation. Let me see. Oh my god, let me see. Yes, A. Why A? Minus, you missing the minus. Okay, let me see. Again, am I missing the minus? Should be plus, right? It should be plus. should be minus. The option is D, not A. You guys are miscalculating it. Yes, the answer is, yes, so you get minus. Yeah, the answer is D, not A. The answer is D. The reduction potential, standard reduction potential is 0. The standard reduction potential is 0, but we are calculating the reduction potential when the pH is 3. So pH is changed, right? Not the standard conditions anymore. Clear? Okay. Okay. Next question. On passing 10 ampere of current for 50 minutes, 2.4 gram of a metal is deposited, equivalent weight. Equivalent weight. Oh my god, simplest question anyone can ask you. Simplest question anyone can ask you. Yes, that's why you need to double check your calculation. pH is negative logarithm of H positive. There we were getting plus, right? So logarithm of H positive will be equals to minus 3. Logarithm of H positive will be minus 3. It's okay, with practice you learn actually. Okay, now solve this question. We know the weight deposited is equals to Z electrochemical equivalent I times T. T is there, I we already know, okay, 10 ampere. Weight is also equivalent weight we need to find. This weight deposited is 2.4 gram. What is Z? Z is nothing but equivalent weight by Faraday. Equivalent weight by Faraday. I'll just substitute the value. Equivalent weight by, what is the value of Faraday? 96,500 times 10 ampere times 50 minutes. I am converting it into seconds. Seconds. Okay. Only this value is unknown to you all. Please answer it. Please answer it quickly, so that we can move on to the next question. So, what should be the answer, everyone? The answer is 7.72. Answer is option B. Oh my god. Option B. Yes, the correct answer is option B. Can we move on to the next question? Yes, we can move on to the next question. Option B. The electrode potential values are given. The most reactive metal, which displaces other metals from their salt solution, will be the one which is getting oxidized easily. Oxidize easily means least reduction potential. Least reduction potential. E naught reduction is the least. Which have the least reduction potential here? I don't want to spoil your answer, but you guys are not answering. Yes, zinc. You are answering zinc. Done. Yes. So, yes, for COMEDK, Govind, we are working on it. Trust me, something will come. Yes. Please be patient. Okay. Yes, the correct answer is D, because it has the least reduction potential. Least reduction potential means the highest reactivity. Highest reactivity. Okay. Next question. Next question. Assertion says E naught cell is less than 0, the cell reaction is spontaneous. That is incorrect, because for, yes, answer it. If E naught cell is less than 0, then does the cell reaction spontaneous? No, the cell reaction is not spontaneous. When a spontaneous reaction happens, Gibbs free energy decreases. Yes, that is correct. These are the two criteria for spontaneity. Your E naught cell should be greater than 0. E naught cell should be greater than 0, and Gibbs free energy should be negative or less than 0. Clear? So that means the assertion is true, but the reasoning is false. That means the assertion is false, but the reason is true. Assertion is false, but the reason is true. D, clear? Yes, E should be greater. Yes, good. The correct answer is option D, and I believe almost all of you answered option D. 35% of you answered D. Okay. Yes, done. Next question. Yes, next question. For an elementary reaction, the rate of appearance of C at time t is this. The rate of disappearance of B you need to find. According to this reaction, firstly, what do you understand by rate of appearance of C or rate of disappearance of B? What do you mean by rate of appearance of C? So this is the rate of appearance of C. Appearance of C. Change in concentration of C with time. Change in concentration of C with time. Okay, I can write it like this also. Change in concentration of C with the time. Okay, this is the rate of appearance of C. What is the rate of disappearance of B? This is the rate of disappearance of B. Change in concentration of B with time. Change in concentration of B with time. Okay, now according to this reaction, what is the relation between these two? The relation is simple. This value is known. This value we need to find. Okay, simple relation. What is it? Minus 1 by 3 change in concentration of B with the time equals to minus 1 by 4 change in concentration of C with time. Clear? This value is known to us. What is the value? This is 2.8 times 10 raised to power minus 3. This is 2.8 times 10 raised to power minus 3. Again, this value we need to calculate. This value we need to calculate. This is plus. This is plus. Okay? So if it is rate of disappearance, these signs doesn't matter. These signs won't matter. This minus and plus sign. Clear? So that means the rate of disappearance of B, the rate of disappearance of B will be equal to 3 by 4 of 2.8 times 10 raised to power minus 3. 3 by 4 of 2.8 times 10 raised to power minus 3. Option A. Clear? Clear. Okay, good. And let me see. Yes, good. Equal, and no one is sure about these answers. Next question. The concentration is reduced from this through this, the rate constant is in 5 minutes. First order reaction, in a first order reaction, the concentration is this, rate constant you need to tell. Do you know this relation, the rate constant relation, which is equals to, for first order reaction, it is 2.303 by T time log of initial concentration upon concentration at time T, the concentration at time T. I'll give you the values. We need to find the rate constant at 2.303, 5 minutes. 5 minutes. The answer is in second inverse. That means minutes need to convert into second. Minutes need to convert into second. Minute, second. Log of initial concentration is 0.6. The concentration at time T reduced from 0.6 to 0.2. If you calculate it, what will be the answer? Give me the answer, please. 3 point, yes. The answer is 6. Yes, C. 3.6. Yes, for question number 72 is C. Avani, good going. Yes. Why you going? Okay, done. For question number 71, no. The vote is coming for 71. No, don't answer that. This is not the question. 1 second. Okay, next question. The reaction is started with 10 gram of A. After 30 minutes and 90 minutes, this much is gone. So, initially the amount was 10 gram. After 30 minutes, 5 gram is there. 10 gram we started with. After 30 minutes, 5 gram is there. Okay, from 5 gram, after more 30 minutes, maybe some amount is there. So, 30, I can do it like this. 60, right? 30 plus 30, 60. And then after 60 plus 30, that means after 90 minute, 5 gram after 90 minute, it is 1.25. That means this would have been 2.5 and 2.5's half is around 1.25. How is the reaction proceeding? How is the reaction going on? Mine is 19%. It's okay. I think you can work. We are doing the question as a mixed match. So I think after some questions, you'll see organic questions. Ma'am, how many assertion reason question we can expect? Assertion reason, are they those? I don't think the assertion reason questions. How many questions? How many I have seen? Not much actually. 2-3 questions I think. Mine are also numb. Yes, I have to move them or else they'll sleep while standing. Tell me the order, tell me the order please. Yes, it is a first order reaction. It is a first order reaction. Okay? Ma'am, 30-90 minutes. Okay, let's say after 30 minutes it got 5 gram. After 30 minutes it got 5 gram, right? After 90 minutes it got 1.25 gram. That means it might have gotten half and then once again half, right? So I just assumed that 30 minutes is the half-life. I just assumed that 30 minutes is the half-life. Why? Because after 30 minutes the initial amount got exactly half. So I just assumed it and I went with my assumption. And after that I figured out that yes, this is working. That means it is a first order reaction. Okay? Okay, done. Mind calculating. Okay, done. Next question, shall we? Yes, next question. The rate of a first order reaction is this. At 0.5 m concentration of the reactant, the half-life. You need to tell the half-life. Can you tell me the half-life? Rate is given. Okay, at this concentration. So firstly you can calculate the rate constant. What will be the rate constant? Rate is equals to K times the concentration of reactant for a first order reaction, right? The concentration is given 0.5. K equals to. Rate will be equal to what? Rate is 1.5 times 10 raised to power minus 2. So you calculate the rate constant using this relation. The rate constant shall be equal to 1.5 times 10 raised to power minus 2 by 0.5. Okay? So that will be 3 times 10 raised to power minus 2. That is the rate constant. That is the rate constant. We are asked the half-life. What is the half-life formula? T half equals to, for a first order reaction, half-life is equals to 0.693 by K, which is 0.693 by 3 times 10 raised to power minus 2. So it will come out to be 23.1 minute, I think. 1 second. 23.1 minute. Yes. So how many of you answered B? Yes. Oh, it's so C, huh? How do you get C? How do you get C here? You guys are just answering it like that. Done? Yes, 23.1 minute. Yes, good. We are done. We carry it forward. Next question. In an endothermic reaction, activation energy for forward reaction is. So whenever we have an endothermic reaction, what is the graph we get? So the graph looks like this. For an endothermic reaction, the energy of product is more than the energy of reactant. Okay, potential energy, reaction coordinate. So the energy of product is more than the energy of reactant for an endothermic reaction. Bye Tanmay, bye, it's okay, bye. Okay, tell me the answer for this question. So the activation energy for forward reaction. What is the activation energy for forward? This much. This is the activation energy for forward reaction. And what is this? This is the activation energy for backward reaction. Which is more? Obviously, the activation energy for backward reaction is more than the activation energy for forward reaction. So, it is less than that for the backward reaction. Okay? More, not more, it's less for an endothermic reaction. Done? Ma'am, many are direct formula logical answer. Obviously, most of them are like that. They are pure KCET questions. So as you can see, you have an idea, right? Okay, next question. The complex ions are octahedral. So firstly you should see what is the oxidation state of iron here, +3, and here it is +2. +3 and +2. 3d6 and 3d5. 3d5 and 3d6. The electronic configuration is 3d5 and 3d6. Now tell me what should be the both are octahedral. We know both are octahedral. What should be the magnetic behavior? Let's check the magnetic behavior. So if it is octahedral, the splitting will be like this. Similarly for this also. Okay, Cn is a strong filled ligand. That means in both the cases there will be pairing. So we'll do the pairing. How many electrons? 5. 1, 2, 3, 4, 5. Okay, here 1, 2, 3, 4, 5, 6. So here in this case all the electrons are paired. In this case all the electrons are paired. That means it is diamagnetic. That means it is diamagnetic. What about this? In this case there is one unpaired electron. Since one unpaired electron is there, it is paramagnetic. It is paramagnetic. So the correct answer is they have same structure but opposite magnetic character. They have same structure but opposite magnetic character. See? Yes. Let me check. Yes, C, correct. It gets strong by talking, by teaching and everything. Okay, let's start. The effective atomic number, EAN, I'll give you the formula. EAN is very simple. It is Z atomic number minus the oxidation state plus Y plus the total number of electrons donated by ligand plus the total number of electrons donated by ligand. In this case, the answer will be 33, I think. Yes, the answer is 33. Guys answered? Some of you answered, right? Yes, Dikshita, Lekhya. Okay, Avani. So tell me the answer. I said the answer, but I think you can still answer it. Okay, so the answer is option, yes, option C. 26. What is the oxidation state here? Plus 3 plus 6 times 2, 12 electrons. Okay, 26, 24. 24. So that is 33. The effective atomic number is 33. Okay, next question. The donor atoms present in EDTA. EDTA 4 minus, how many donor atoms are there? What are the donor atoms? So I think this is the structure of EDTA. I am drawing the structure. Till then you answer me what? Negative, right? O negative. Because EDTA 4 negative is there. Okay. I am drawing the structure. Tell me the answer till then, please. This is the structure of EDTA. How many donor atoms it have? These 2 nitrogen atoms can donate, right? Similarly, these 4 oxygen atoms, they also can donate, right? Protonated and all, right? Deprotonated and all. Yes. 2 oxygen. 4 oxygen, yes, it has 4 oxygens and 2 nitrogen atoms. So 78, the answer is D. Have you seen that KBC thing, right? There it goes, pole up, audience pole, audience pole. So this is like audience pole. It's nice. Has 2 nitrogen and 4 oxygen. It's okay, Joe. That is the EDTA structure. Very simple. CH2, CH2N, COH, COH. Sorry, CH2, COH, CH2, COH, CH2, COH, CH2, COH. Okay. If it is not in your class, you can learn here also. Okay. D. Done. Next question, shall we? Yes. In which of the following octahedral complexes will the magnitude of this is highest? Crystal field splitting energy is highest for strong filled ligand. Strong filled ligand. I'll give you the sequence. So in here you have H2O, then you have NH3, then you have C2O4 2 negative, and then you have Cn. H2O, NH3, no. Did I miss? Yeah, this goes below actually. Cn, NH3, H2O, oxalate. So which will have the highest magnitude of crystal field splitting energy? Strong filled ligand, the strongest filled ligand among these, which is Cn, and yes, all of you answering B. Good. So the correct answer is option B. Shortcut to remember the order. Have a general idea. Halides, then you have oxygen compounds, then you have nitrogen compounds, and then you have pi acceptors. Just a general idea like this you have, na? And then remember the one which are there in the top, which is your pi acceptors. What are those pi acceptors? Okay, 2-3 examples are there. CN is the strongest one. You remember them, COCN, right? Okay, that is a general idea. Okay. Next question. The IUPAC name of this one. The IUPAC name of this one is, this is cation, this is anion, right? What is the charge on this nickel? Cross valency. 2 is there, so nickel is +2. Cobalt has +3. Okay, now see, hexamine, nickel 2. Now this is anionic complex, right? So cobalt will become cobaltate. Okay, hexanitro, cobaltate 3. Hexanitro, cobaltate 3. Which is the correct answer? Which is the correct answer? Tell me the correct answer. Yes, the correct answer is option A. Yes. Okay, good. Correct answer is option A. Yes, good. Okay, next question. Upon reaction with alkaline KMnO4, which one of the following is not converted to benzoic acid? For conversion to benzoic acid, only one thing we need. What? What do we need for conversion to benzoic acid using KMnO4? Only one thing we need, that is one benzylic hydrogen. It should have at least one benzylic hydrogen. One benzylic hydrogen, okay? Does it have? Yes, it does have one benzylic hydrogen. Does it have? Yes. Benzylic means the carbon that is connected to the benzene ring. The carbon that is connected to the benzene ring, that is the benzylic carbon. And the hydrogen that is connected to that benzylic carbon is benzylic hydrogen. Okay? So, again, this doesn't have. This is there. Yes, it gets converted. Ruko. Not converted into benzoic acid. Not converted into benzoic acid. Yes, so the correct answer is option D. D. It doesn't, because it doesn't have any benzoic. In this case, this is there. In this case, CH3 is there. This is the alpha carbon in this case. Yes, the correct answer is D. Yes, the correct answer is option D. Next question. For propanoic acid undergoes HVZ reaction, gives chloropropanoic acid. So this is propanoic acid and this is chloropropanoic acid. Which is more acidic? Which is more acidic? 1 or 2? Which is more acidic? Obviously chloropropanoic acid is more acidic, right? Yes, the chloropropanoic acid, yes. It won't get converted into benzoic acid. That's why. So tell me which is the correct, which is more stronger acid? The product obtained is chloropropanoic acid. Is chloropropanoic acid strong acid or weak acid? I'm waiting. Let's do till 30 votes at least. 30, then I'll check. 1, 2, 3, yes. So the correct answer is yes, C. That is correct answer. C. Stronger acid than chloropropanoic acid is stronger acid than propanoic acid. Okay? Done? C? Yes. Good. Yes, it is stronger than, Amok, correct, it is stronger than propanoic acid. Next question. The product in the following reaction sequence are, firstly you identify, this looks like a Cumin process, right? This looks like Cumin process. So first step, Friedel-Crafts alkylation. This is the product you will get. X will be this. This is X. This is X. isopropyl benzene. This is isopropyl benzene. This is X. Okay. Now after that, this X is heated with oxygen at 130 degrees Celsius. It gets converted into cumene hydroperoxide. Cumene hydroperoxide. Okay. This is cumene hydroperoxide. You give the answer till then. Cumene hydroperoxide, that is your Y. And on hydrolysis, cumene hydroperoxide on hydrolysis give two compounds, phenol and acetone. Phenol and acetone, CH3COCH3. So X is what? Read the question. We are being asked X and Z. X is what? X is your isopropyl benzene. Yes, X is isopropyl benzene and Z is acetone. X is isopropyl benzene and Z is acetone. Yes, the correct answer is option A. Clear? Yes. A. Trisha is shouting A. Yes. Kani, whatever doubt you have, Macha, wait for some time. After 100, we'll answer your doubts, okay? Any question you have doubt in, we'll answer it, okay? Yeah. Next question. Reaction of propanol with methyl magnesium iodide followed by hydrolysis yield. Where was that guy who was asking organic question? Here you are the organic question. Okay, now listen. Propanol. This is propanol, right? Reaction of propanol with methyl magnesium iodide. Methyl magnesium iodide followed by hydrolysis. Firstly, this is a Grignard reagent. This is an Grignard reagent and this is a ketone. How do they react? What will be the product? This will be the product. COMGI. There will be CH3 and this CH3 will get attached. Okay, clear? This is the product. After hydrolysis, after hydrolyzing this product, what will we get? This O, alcohol. This O will get converted into alcohol. So we will get CH3C, CH3, CH3OH. Tell me the name of this one. Tell me the name of this one. So among that depends. If you want to solve the questions, the PDF will be updated a little later. You can start from beginning and watch the live again, solve the questions and then do a revision later on when you get the PDF on the WhatsApp channel. Okay. So what is the answer? I gave you the product. Yes, the correct answer is option D. This is 2-methyl propane 2-ol. 2-methyl propane 2-ol. Done. Ma'am, it's easy. Oh, okay. C. No, Avani, the product is D. Why? Because this is what happens when you react any carbonyl compound with Grignard reagent. Whatever R group is there, it gets attached to that carbonyl carbon, okay? And this O normally gets converted into OH, that is alcohol, okay? Ma'am, it is simple. Yes, I know it is simple. Next question. The order of reactivity of the following alcohols towards dehydration. Dehydration. So when we talk about dehydration, we talk about carbocation stability. Stabler the carbocation, easily the dehydration will happen. Stabler the carbocation, easily the dehydration will happen. So just think, when you are doing dehydration, you are removing this, and the double bond is getting formed. A double bond is getting formed. Two possibilities are there. So this carbon, our main focus is this carbon. If this carbon forms a stabler carbocation, then obviously the reactivity will be really high. Yes, third butyl alcohol, correct. Tell me the answer for this. What should be the order? I know one thing, that this is the highest. This is the highest stable. Why? This is the most stablest carbocation. It is a tertiary carbocation. 1, 2, 3, right? So max will be 2. So either it will be option B or D. Okay. Least is also there. In between 1 and 3, you have to decide. 1 and 3. These two you have to decide. Now see, here there is one possibility. This is a secondary carbon, this is also a secondary carbon. But here, if we shift that positive charge to here, and we remove this here, okay, then in that case, this is a tertiary carbon. That means a rearrangement can happen. Okay. So in between 1 and 3, 1 will be more reactive. How many of you answered C? 33%. So there is a tie between option A and option C. No one is good at organic chemistry, but you just got a got to be pretend that you are good at it. Okay, it's okay. It's very easy in your syllabus, whatever it is given. It's very easy. Yes, the correct answer is option C. Okay, so in between these two we have a tie. The maximum stable we know, the minimum stable we know, but in between these, why we had the doubt? Because both are secondary carbons. In this case, a rearrangement can happen, and because of that rearrangement, this is more stabler than 3. This is more stabler than 3. Thus the product, this is more stabler than C, then this one will be more reactive. Okay, done. C. Next question. An aromatic compound with molecular formula turns orange color of potassium dichromate green. Orange color of potassium dichromate green. I don't know. Let's say I don't know this reaction at all. Okay. Okay. Let's say I don't know this reaction at all, but I know. But let's say if you are doing it and you by any chance you don't remember this reaction, just look at the answers. Look at the options. Just look at the option. One is odd one out, which is very easy. All of these are phenols, only one is not phenol. It's a benzylic alcohol. It's a benzylic alcohol. So which of the following with molecular formula turns orange color into of potassium dichromate green? That means this, right? Because this is the odd one out, right? Even if you do not know the reaction, you can still solve it. You can still solve it. Yes, the color is because potassium dichromate is a strong oxidizing agent. This get oxidized to benzoic acid. Okay, that is the reason for the green color. It gets converted into, yes, benzoic acid. Okay. So the correct answer is option A. Even if you do not know, you could have answered it. Yes, good. Next question. A compound of metal and this is the spin on the magnetic moment. Unpaired electrons. Unpaired electrons, square root of n into n plus 2 equals to 15, right? What should be the n? N should be 3, right? 3 into 3 plus, no, 15, right? 15. So this should be 3, yeah, 3 into 3 plus 2. That is square root of 15. So that means the number of unpaired electrons, this should be like come and go. Why not B? Why not B? Why B? This is phenol, right? This is phenol. It won't react. This will react, will get converted into benzoic acid. This will not. Okay? 1 second. Option D. Any doubt you have, I'll answer. Just wait for some time. We are almost done. Yes? Done. Next question. The reason for the stability of gadolinium, this name is gadolinium ion, gadolinium ion. So the electronic configuration is this one, 4f7, the electronic configuration is 4f7, 5d1, 6s2. 4f7, 5d1, 6s2. So when it is GD3 positive, 3 electrons are getting lost. So these 3 electrons are getting lost from 6s and 5d. These electrons are getting lost from 6s and 5d. What configuration is there? 4f7, that means half filled configuration. That means half filled f orbital. Half filled f orbital. That is the reason. That half filled f orbital is the reason for the stability of GD3 positive ion, gadolinium ion. Okay, that is half filled f subshell. Half filled f subshell. Yes. So how many of you answered A? Almost all of you answered A. Good one. Next question. The number of moles of KMnO4 that we needed to react completely with 1 mole of ferrous oxalate in acidic solution. So here little story is different. We have done this type of question before, but that story is different. How? MnO4 negative will get converted into Mn2 positive. Mn2 positive, right? 7. Okay. Mn2 positive, yes, here it is plus 7. Yes, it is plus 7. From plus 7 it is getting converted into plus 2. How many electrons? 5 electrons, right? 5 electrons, okay. Ferrous oxalate, which is Fe. Ferrous oxalate is FeC2O4. Iron, Fe2 positive, will get converted into Fe3 positive plus 1 electron. C2O4 2 negative, again will get converted into 2CO2 plus 2 electrons. So how many electrons are available? 3 electrons are available. How many electrons are required? 5 electrons are required. We need to calculate the number of moles of KMnO4 that will be reduced, that will be needed to react completely with 1 mole of, this is 1 mole, 1 mole of ferrous oxalate. So ferrous oxalate is providing 3 electrons. 1 mole of MnO4 needs 5 electrons. Okay, so we need to calculate the number of moles. We did the same method back, right? The number of electrons needed for reduction should be equal to the number of electrons needed for oxidation, right? That are provided by oxidation. So X times 5 should be equals to 1 times 3, right? So X will be equal to, the number of mole will be equal to 3 by 5. So the number of mole of KMnO4, that will be needed to react completely with 1 mole of ferrous oxalate is 3 by 5. It is 3 by 5. Clear? Done? Yes, the correct answer is A, and much as all of you answered A. Yes, A. Good. Okay. Next question. Alkyl halides on treatment with suspension of Ag2O moist. So two cases are there, when Ag2O is moist and when Ag2O is dry. When Ag2O is dry, this is moist and this is dry. So in both the cases we have different compounds. When it is moist, we have, it is like AgOH. So the group that it provides is OH. The group that it provides is OH. So in that case we will get alcohol. If this is the reagent here, so then the product will be alcohol. The product will be alcohol. If Ag2O dry is there, in that case Ag2O dry is there, in that case it provides oxygen. So that means we will get ether. What is here? Moist. Moist means alcohol. Moist means OH group. It will provide OH group. OH group means alcohol, which means, tell me the answer. I don't want to say it. Tell me the answer. Yes, alkenol. The correct answer is alkenol. Rachna, you should not actually. I don't know what to do. I don't know what is going on here. Give me some time. We are almost done. Okay, 10 more questions to go. Are you ready? Next question. Yes. Okay, is it visible to you all? Tell me the product. First case, nitrobenzene is there. When we do nitrobenzene, what is this? Bromination of nitrobenzene. What is the product? When we do bromination of nitrobenzene, again we will get meta-nitrobenzene, meta-bromo-nitrobenzene. Meta-bromo-nitrobenzene. Again, tin concentrated HCl, that means this nitro will get converted into NH2. Reduction of nitro compounds. This is the reduction of nitro compounds. Yes, 10 more to go. 1 second. Okay, so there is a tie between A and B. Some are there. Okay, now listen. We get meta-bromo-nitrobenzene, right? If we treat it with tin and concentrated HCl, this nitro will get reduced to aniline. This will be the compound NH2, and at meta position there will be bromo. Now again, this is disonium salt, and if you provide water to it, that means firstly this will get converted into this N2 positive Cl negative, and then if you add water and warm it, it will get converted into OH. It will get converted into OH. So that means meta-bromophenol. Meta-bromophenol. Yes, and all of you answered A. All of you answered option A, metabromophenol. Metabromophenol. Next question. The correct increasing order of basic strength. Para-nitroaniline, para-bromoaniline, para-toluidine. Okay, this is para-nitroaniline. This is para-bromoaniline. Bromo. And this is para-toluidine. Para-toluidine. So again, toluidine. So again, depending on the group, CH3, NO2, Br. CH3 is electron donating group. Electron donating group increase the electron density on this nitrogen. That means it will be able to donate electrons more easily. So this will be the most basic. 3 is the most basic. Then among these, number 1, this is number 1, this is number 2, and this is number 3. Among 1 and 2, 2 is more basic. Why? Because again, bromine and nitro. Nitro is purely electron withdrawing. Only minus I is there and minus R is there. Okay. Here we have minus I, but plus R is also there. It does donate some electron density to the ring. Okay. So that's why among 2 and 1, which is more acidic, more basic, 2. Right. So what is your correct answer? Let me check once. You guys are answering. It should be increasing order of basic strength. Yes, it should be C. How many of you are answering C? You guys are stuck in A. Yes, so the correct answer is C. This is the most basic. 3 is the most basic. Then 2 and then 1, because it has only plus I. It has only plus I. This is minus I and plus R. This is minus I and minus R effect. Okay. Next question. Which of the following is a non-essential amino acid? Proline. Proline is a non-essential amino acid. That is your proline. Again. Yes, for 93 the answer is D. Good. 94. Okay, tell me the answer for 94. Wrong statement you need to tell me. Wrong. I think 1 is wrong. So glucose is cyclic acetyl structure with its CHO group. Glucose does not form acetyl. It forms hemiacetyl. Glucose form because it has only one CHO group and it forms hemiacetyl, not acetyl. Okay. So the incorrect statement is option C. Rest are correct. Okay. It forms cyclic hemiacetyl, not acetyl. Okay. You guys answer it, I'll check it. Okay. The conjugate base of NH3. Conjugate base. When do we get conjugate base? When an acid lose a proton, we get conjugate base. So if it is an acid and it lost a proton, we will get NH2 negative. We will get NH2 negative. That will be its conjugate base. Similarly, if base accept a proton, they become conjugate acid. Clear? Okay. Next question. Solubility of AgCl is the least in. So have you heard of that one effect called common ion effect? Have you heard of the one effect that is your common ion effect? Yes, good. Common ion effect. So common ion effect will suppress the solubility, because if a common ion is already there, the solubility will be less because already that specific ion is there. Okay, the system does not want to disturb its equilibrium. So due to common ion effect, more AgCl, more Cl, less solubility of AgCl. More Cl negative ion, lesser will be the solubility of AgCl, which has the most Cl negative ion, most in this one, I think, right? 3 Cl negative, 2 Cl negative, 1 Cl negative, 0. So the minimum least solubility will be for this one. Least solubility will be for option D, and yes, all of you are answering option D. Good. Yes, next question. Yes, we are done almost. The number of electrons in a mole of hydrogen molecule. How many electrons are there in a mole of hydrogen molecules? Mole. Tell me. In a mole of hydrogen molecules, 97, I'm happy. Number of electrons in a mole of hydrogen molecules. Two electrons, right? 2 electrons means in a mole of hydrogen molecules, how much electrons we need? 2 electrons we need, right? 2 electrons. So 2 electrons means 1 electron needs Avogadro number, right? 2 electrons means twice of that. So that is option B. I can't see some of you answered A and A. No, it's B actually. The correct answer is option B. Next question. What is the oxidation state of nitrogen for both of these? Both of these, very easy. One is NH4 positive, other is NO3 negative. What is the oxidation state? NH4 positive and NO3 negative. If I am correct, tell me. -3 plus 5, -3 plus 5. Ma'am, but how? 1 second, whatever doubt you have, I'll answer it. Sorry, -3. Yes, there will be -3. Okay. Now I have the phone, I can look at your answers. So in the last question, the hydrogen, to convert H positive into hydrogen, we need how many electrons? 2 electrons. For 1 mole of hydrogen, how many electrons are involved? 2 electrons are involved. For 1 mole of hydrogen, we need 2 electrons. So, and 1 mole of electrons have around Avogadro number, right? Avogadro number of atoms. So 2 mole of electrons will have 2 times of that Avogadro number. Okay. Sorry. Yes, +3 and -5. +3. Not -3 and +5. -3 and +5. No. NH4 positive. X plus 4 equals to +1. X will be equal to +1 minus 4, which is -3. No? Yes. Okay. A. Done. Machas, 2 questions left. I can't believe we did this. Hey, it's easy. You can do. Last question, can I give you homework, please? Can I give you the last question as homework, guys? Yes. Can I give you the last question as homework? This one I'll solve. Number of angular nodes will be L, and the number of radial nodes will be n minus L minus 1. N minus L minus 1. So, yeah, nearly 5 hours. Yeah, I know. Okay, tell me. What are the number of angular nodes for 3p? P means L value is what? 0, 1, sp, 1. Okay. This also 3, n is 3 minus 1, that is also 3. This one is actually very easy. Don't do this. You guys are answering wrong now. Yes. Correct answer is option B. Please, what is there? Angular nodes is L, and the number of radial nodes is n minus L minus 1. Okay, we'll solve the question, don't worry. Last question. Correct order of radius. Simple. Correct order of radius. You answer it or you take it as a homework, whatever it is, and now ask me whatever doubt you had. Okay, I'm here for 2-3 minutes. Yes, this is the correct. negative, neutral and positive. Cation have smaller size, anion have larger size, and in between comes the neutral. Again, this is the same number of electron but positive, negative, -2. Again, this is here but 2 negative is there. 2 negative means the charge is larger than 1 negative. Yay, 100 is done. Congratulations. Actually, I clap for myself also. I didn't know I could do it. So please answer for it and then we are done. Yes, 100%. Finally, 100% for A. Finally. Okay. Ma'am, are these JEE? No, Amok, these are KCET questions. They are not JEE questions. Finally done. Yes, I tried to explain you guys in between also. So please tell me if you guys have any other doubts. I think I broke my clutcher also. Okay. If you guys have any other doubts, tell me. Ma'am, what to do? Okay, I'm here only. It will be a gym workout. You know, you've burned equal amount of calorie. The same calorie would have burnt in gym. Okay. Okay, PU full shot revision. Wow, full shot. Let's see. Okay. I hope it was worth it, Joe. 0% prep. Arohi, Jasmine ma'am has made a video about that, covering. I can only tell you about chemistry, right? But she has covered all the physics, chemistry, biology, maths. So you can watch her video, last 10 days strategy and something. She actually explained it really well, and also the resources are also she has given. So you can watch that video. Refer to that video, please. Okay. Ma'am, I can't do physics, only chemistry, maths I did till now. Avni, then from physics also there are some chapters which are easy and high weightage, so you can do those chapters at least. Okay. Okay, thank you. 51. Yes, 1 second. 51. You ask any doubt you have. We are solving them now. Oh, sorry. Geometrical isomers, right? Plane, we have square planar complex A, B, C, D. So what we did, geometrical means cis trans isomers. Okay. So let's say if I'm fixing my A here, then 3 arrangements are possible in case of geometry. Let's say if I'm taking that C and A, I'm only focusing on C and A. In this position they are trans. Okay. Here they are cis. Okay. Again, here they are cis, but there's one more possibility. So geometrical isomers means you're having different possibility, different arrangement for same compound complex is possible. Okay. Optical is not possible for square planar. Why? Because it has a plane of symmetry. Whenever a plane of symmetry is there will not be any optical isomers. Okay. Geometrical isomers, as in if you see here, 2 cis form are there. There are 2 forms of cis and 1 form of trans. If I'm just taking C and A, I'm only focusing on C and A, this is one trans form and these 2 are cis form. Okay, they are different because in this case B is opposite to A and in this case D is opposite to A. Okay, so 2 cis cases and 1 is trans. Okay, that's why 3 geometrical isomers. Arvind, the CFSC value is different. That is about ligands. C2O4 negative is stable. I'm not counting that their crystal field splitting energy. The crystal field splitting energy for C2O4. 1 second. We are talking about strong filled ligand and weak filled ligand. The strong filled ligands have high crystal field splitting energy. And which is a strong filled ligand? Cn is a strong filled ligand, then C2O4 2 negative. Okay, so it's nothing about their stability and all, it is all about that crystal field splitting energy. Okay, yes, it will be useful, Trisha. 1 second. Weak at organic chemistry, it's okay. If you're weak at organic chemistry, complete your name reactions, have some basics and all. Okay, solve the questions because you learn more from questions than rather cramming everything, because I know the organic chemistry is really tough. You have preparation, you have physical chemical properties, but you solve the PYQs, last 10 years PYQs at least you solve. What will happen, you will have an idea on what kind of questions are being asked, which kind of reactions are being asked repetitively, because I have seen it, many reactions get repeated every year, same reactions. Okay, yes, just 5 days to go. So start from question. Please solve this. 68th, please 1 second. Okay. Equivalent weight you need to calculate here. So we know the weight deposited is equal to ZIT. Z is electrochemical equivalent, I is the current, and T is the time. Okay, this is Faraday's first law. Okay, what is electrochemical equivalent? Electrochemical equivalent is equals to equivalent weight by Faraday. This quantity you need to find. This we know 96500. We just substituted the value here. All the values were given to us. Only this value was unknown to us. Okay. You can write the electrochemical equivalent is equals to equivalent weight by F. Okay. 75. Like in endothermic reaction, activation energy for forward reaction is, activation energy means the energy that you need to provide to reactant so that the reaction can happen. This is the activation energy barrier, right? So this is the energy you need to provide the reactant so that the reaction can happen. Similarly, if I want backward reaction, then the product should have this much energy so that the reaction can happen in the backward direction, right? So this is the activation energy for backward reaction, and this is the activation energy for forward reaction. The question asked, the activation energy for forward reaction is less or more. So as you can see, this is the forward activation energy for forward reaction. This is the activation energy for backward reaction. Obviously this is large, so obviously the activation energy for forward reaction is less than the activation energy for backward reaction. Okay, activation energy means the minimum energy required to convert the reactant into product. This is the minimum energy you should have. Okay. So if stability is asked, then depends on what kind of thing it's being asked. Normally they won't ask you just straight away. If it's in coordination, they will base it on CFSC only, crystal field splitting energy. There's no relation of stability that is being asked there. Okay, that's a different thing. Cn negative is actually more stable than you think for C2O4 negative. Cn negative is more stable actually. Okay, so Joe has it out. See, listen. If you have an alkyl halide and if you treat it with, one is NaCN and other is AgCN. So firstly, both the compounds are different. This is an ionic compound. This is an ionic compound, and this is a covalent compound. This is a covalent compound. So when an ionic compound is there, we have Na positive and Cn negative, right? So Cn negative means carbon electron is also free, nitrogen electron is also free, right? Two possibilities are there. Either can bond can form from the carbon side or can form from the nitrogen side, right? Clear? Now, I think with AgCN you get RNC. Here you get RNC and here you get RCN, because in here you have two possibilities. Either carbon can form bond and nitrogen can form bond. But since here this is alkyl group, that means this is carbon. So carbon-carbon bond is much stronger than carbon-nitrogen bond, and because of that reason, when we treat alkyl halide with NaCN, we get RCN. Because we have two possibilities, but since the carbon-carbon bond is more stronger, RCN gets formed. Okay, if we have a covalent compound, AgCN is a covalent compound. Okay, so covalent means there is a bond between Ag and C, Ag and carbon, right? So the carbon electrons are not available for donation. Firstly, the carbon electrons are not available for donation, so only nitrogen electrons are available, right? So that means this nitrogen will donate electron, right, and form a bond, and here we get isocyanate. Here we get cyanide and here we get isocyanate. That depends on the nature. Okay, electrons are available here, that's why carbon-carbon bond formed. Here electrons are not available. Here electrons are not available. Okay. Is it clear, Joe? Yes, you can still crack it, Amok, because I've seen you answering. You are able to answer questions. So yes, you can still crack it. 75 I explained again. I don't know what you're not understanding. Please explain to me what is your doubt actually. Okay, you guys are just spamming at this point. Yes, you can leave. You don't have any doubt. There is no class today. There is only my class today. EDTA, the structure of EDTA. See how many donor atoms it have. It can donate it can donate this electron pair, and these 4 electron pairs are already also there, right? 4 oxygen. So the donor atoms are 2 nitrogen and 4 oxygen atoms. Clear. Thank you. Okay, now you just. Yes, energy of product is more for endothermic because they absorbed energy. 68 and 82. Let me see. I just explained 68, I think. Okay, guys, I think we're done. I just explained it. I'm not explaining it again. Okay, there's nothing to explain actually in this one. Yeah, obviously I'm tired. Because you guys are not asking me nice questions. 82. 1 second. Propanoic acid. So in between propanoic acid and chloropropanoic acid, which is stronger acid? This one, because it has minus I, chloro, right? Minus I, and due to that minus I, it is a stronger acid, right? So in between these, which is a stronger acid? Chloropropanoic acid. So the answer is the product, which is their chloropropanoic acid, is stronger acid than propanoic acid. Okay? Yes. What was your doubt, Queen? Tell me your doubt. Break, class is over. Go. Avni, the next video will come. Ma'am, how to remember which reaction is used in the given reaction equation? Reagent, you identify with the 2 things. First is your reactant, what reactant is given to you, and second your reagent. Only these 2 things you need to learn. Reactant, reagent, and then obviously product. I think I'll make a video about name reaction and all, so in that I'll cover it up, okay? Queen, what was your doubt? Okay. Don't be too worried about me, okay? I can take care of myself. You focus on your studies, take rest, take care. Questions, do solve lots of questions and revise, okay? Okay. Next class will be, I don't know, I think next week. It will be next week, I think. Bye everyone. Okay, thank you so much for joining such a long class. I really appreciate you all. You guys solved the question till the end. Okay, and if by any chance you still have some doubt left, okay, Sushmita, I'll let you know in the I'll ask and then I'll let you know. Okay, don't worry, I'll answer your doubt. Do one thing. Once this live is over, write it out in the comment section, then I'll reply, okay? That's actually very good, Joe. Yes. Okay, so I'll explain one more question. Okay, 4th question, then we're going. Okay, bye everyone. Okay, and Sushmita, yeah, do mention your doubt, whatever it is in the comment section. I'll reply. Okay. Okay, so 4th question is the last, then we are ending the live. Okay. Hybridization. Do you know how to calculate hybridization? You have two methods to calculate hybridization. First is this one. Calculate the number of sigma bonds plus the number of lone pair of electrons, right? Calculate the number of sigma bonds plus the number of lone pair of electrons, right? So simple. That is one method. Second is this one. Half of number of valence electrons plus the number of monovalent atoms minus the charge of cation plus the charge of anion. We calculated that. So only these two have sp3 hybridization. BeH2 has sp hybridization. BF3 has sp2 hybridization. We are looking for sp3. When we calculated, whichever formula you choose, you calculate it, and the answer will be sp3 hybridization. Okay, that means the steric number is 4. Steric number is 4. Clear? The God's Learning channel, is it clear? It's confusing you because I've given you two formulas. So whatever formula you have learned, go through that question. Done? Just try it once again with you. Sit down, and whichever formula you find nice, you use that formula, calculate the steric number, and from that you'll get the idea about hybridization. Okay? I have explained it. I don't know what else you want me. There are two formulas. With the formulas, I can't help you much. You have to learn them. Number of sigma bonds plus number of lone pair of electrons, and then half of, this is one other formula. So if you're using that, use that formula. Don't mess it up. Okay, I think you guys are he's just spamming, I think, his point. Okay, done. Okay, thank you everyone. Thank you for the lovely class. I'll upload the PDF, and you guys please study. Thank you so much. Okay. Take care. Bye-bye. Thank you. Yes. We'll discuss all your doubts in the next class. If you have any other doubts, please come bring them in the next class, or you can mention them in the comment section of this video. I'll answer your doubts. Okay. Take care. Bye-bye. All the best. Yes. Bye.